Okay, good evening. Can you hear me? Good evening. Okay, good evening. Let's get started. Yesterday, we have introduced diode circuits, and I mentioned that a diode is a logarithmic device, not an exponential device, and a diode can be used as a switch. And we have seen that solving diode circuits is very difficult if you treat the device as a nonlinear device, because you have to apply some sort of numerical analysis or trial and error method. Instead, we converted the nonlinear diode characteristics into simple piecewise linear characteristics. When we look at the piecewise linear characteristics, we have to take only one segment at a time, and that allows us to solve diode circuits by all the network analysis that we have studied. We can apply Thevenin and Norton superposition. Otherwise, the diode problems are quite difficult to do, right? So let's get started. Let's see how we can solve simple diode circuits. So our main aim in this session is to see simple diode circuits, single diode problems, and multiple diode problems. We will see peak detector, clipper, clamper, voltage multipliers, and we will combine op-amp with diodes, and we will see precision circuits also, right? So yesterday we have done a problem. Take down find ID if VD on equal to 0.7 volts. VD on equal to 0.7 volts. So how do we solve diode problems? Okay, to solve diode problems, last class I mentioned that the piecewise linear characteristics. If VD equal to 0, that means the diode is replaced by 0.7 volts. Then you have to find ID. If ID is greater than 0, then diode is forward bias. Diode is forward bias. Now what if it fails? If it fails, then we have to come to the second segment. In the second segment, if ID equal to 0, that means the diode is replaced with open switch. Find VD. If VD is less than 0.7 volts, if VD is less than 0.7, then the diode is reverse bias. So this is a simple test we are going to apply now, right, for diode problems. So how do we solve this? Let us assume 0.7 volts here. 0.7 volts. This node is at 0.7. We have to find ID. Let us take some current I1 and I2 and apply KCL, right? The currents entering is equal to the currents leaving. I1 equal to I2 plus ID. I1 equal to I2 plus ID. So what is I1? I1 is 8 minus 0.7 by 1K. And I2 is 0.7 by 1K plus ID. So ID equal to 8 minus 1.4 milli. That is going to be 6.6 milliampere. So this is positive. So as ID is greater than 0, the diode is forward bias. As ID is greater than 0, the diode is forward bias. Now we can do by method 2. We can do by source transformation. In source transformation, the V in series with R, we can replace it with 8 by 1K in parallel with R, 1K. So you have an additional 1K here and then a diode. Now, what is 1K parallel with 1K? That is 0.5 kilo ohm, right? 0.5 kilo ohm. So 8 by 1K into 0.5K is a voltage. 8 by 1K into 0.5K is going to be 4 volt in series with 0.5K. So this is the source transformation, and here we have a diode that takes a drop of 0.7. That takes a drop of 0.7. So what is ID in this loop? What is ID? You can apply KVL, or ID is 4 minus 0.7 by 0.5K, right? Or you can apply KVL here. KVL minus 4 plus ID into 0.5K plus 0.7 equal to 0. So your ID is 4 minus 0.7 by 0.5, 3.3 by 0.5, 6.6 milliamp. So you can solve the problem by source transformation also. Consider diode ideal. Find ID. Consider diode ideal. Find ID. Now, in the previous problem, we have replaced diode with 0.7 volts. Now you have to replace diode with a short circuit. So if a diode is ideal, how will you solve diode problems if it is ideal? If the diode is in this segment of the characteristic, it says that if VD equal to 0, find ID. What do you mean by voltage 0? I told you voltage 0 means short circuit. The diode is replaced by short circuit. Find ID. If ID is greater than 0, then diode is forward bias. This first segment. Now what about the second segment here? The second segment. The second segment says that if ID equal to 0, what do you mean by ID 0? Current 0 means open circuit. If you replace the diode by open circuit, you have to find VD. If VD is less than 0, then the diode is reverse bias. Then the diode is reverse bias. So let's solve. We have 9 volts. Whenever I say plus 9, where is minus? Minus is connected to ground. Whenever I say 9 volt, the minus is connected to ground, plus 9 is connected to 3K. All right. This is connected to 3K. And then the 3K is connected to 6K. 6K. In between 3K and 6K, you have a diode. And here you have 3K, 6K, and plus 9, minus is connected to ground. So this is the circuit, right? So you can as well do by source transformation. Or you can do by Thevenin also, right? So what is the equivalent of 9 volts with 3K and 6K. So what is the open circuited voltage here? VOC 9 into 6 by 3 plus 6 is going to be 6 volt. What is the R equivalent here or R Thevenin? If you short the voltage source, 3K parallel with 6K. What is 3K parallel with 6K? 3 into 6 by 3 plus 6. 3 6 are 18, 18 by 9 is 2K. So I can have 6 volts in series with 2 kilo. So this is when you try to cut it here. What if you try to cut it here? What is the equivalent? The equivalent for this is 9 into 3 by 6 plus 3 is 3 volt. In series with 3K parallel with 6K is again 2K. So now in the middle, we have a diode, right? So we have a diode in the middle now. So replace diode by short. So what is ID now? ID equal to 6 minus 3 by 2K plus 2K. 3 by 4, 0.75 milliampere. Positive, right? ID greater than 0. Therefore, diode is forward bias. ID is greater than 0. Therefore, the diode is forward bias. Method 2, you can do by source transformation. Source transformation. So you have 9 volts with 3K. How you can write? 9 by 3K in parallel with 3K. 6K. Here you have a 3K. (6K). This is 9 by 6K. 3 milliampere. 1.5 milliampere. So what is 3K parallel 6K is 2K. This is also 2K. So 3 into 2 is 6. You have 6 volts in series with 2K. I'll replace diode by short circuit. This is a diode. Then 1.5 into 2 is going to be 3 volt in series with 2K. So what is the current ID? ID is, you can apply KVL, or ID is 6 minus 3 by 2K plus 2K. It is 3 by 4 milliampere or 0.75 milliampere. So you can do by any method you wish. So if the examiner says VD 0.7, you can replace the diode by 0.7. Otherwise, you can replace the diode by short circuit, calculate the current. The current is positive, then the diode is forward bias, right? See, last class, we have seen that this is a problem we have seen last class, 2 volt, 1K, and there is a diode here, right? Now just see here, if I take this node as ground, the cathode voltage is at 0. And what is the open circuited voltage here? Open circuited voltage, or the anode voltage here? It is 2 volt. So when I say the current ID is positive, current always flows from higher potential to lower potential. So ID positive means your anode voltage is greater than the cathode voltage, right? Your voltage at anode, the open circuited voltage at anode is greater than cathode. That is when the diode will sustain a positive current. So how do we define forward bias? So one way of defining forward bias is a diode is forward bias when anode is more positive than cathode. So you can say that the diode should sustain a positive current, or when you say that the current is positive, the current is always traveling from a higher potential to lower. So who is at higher is the anode voltage, who is at lower the cathode voltage. So when you replace the diode, you can calculate the open circuited voltage here 2 volt, and ground, one end is ground. So with respect to ground, that is 2 and this is 0. So diode is forward bias when anode is more positive than cathode. Am I right? So I'll, in a simple example, another example. So what if this is minus 3 volt and here you have minus 7? Minus 3 and minus 7, right? So which is a bigger number, right? In integers, you know who is a bigger number. Minus 3 is much bigger than minus 7, right? So when you do the potential difference, naturally the current is going to be positive, right? So what is ID here? If you replace the diode by short circuit here, this end is minus 3, this end is minus 7, 1K, and you have ID. What is ID? It is minus 3 minus of minus 7 by 1K. So it's going to be 4 milliampere positive. So remember, current will be positive only when it is traveling from a higher value to a lower value, right? In positive values, 7 is larger than 3, but in negative values, minus 3 is much larger than minus 7. So who is larger, minus 3 or minus 7? So definitely anode is still at a higher potential than cathode. So the diode is still what bias? Forward. The diode is still forward bias. So one more definition now, a diode is forward bias when the anode is connected to the plus and cathode is connected to the minus of the source. That means a diode is forward bias when anode is more positive than cathode. The anode should be more positive than cathode, right? Or if you want to cross check this, what is ground? Ground is generally a reference, right? What if I lift all the voltages up by 10 volt? Suppose I have a circuit and I lift every voltage up by 10 volts, the currents are not going to change, right? So ground is only a reference now to measure with respect to that point, right? In order to compare one voltage with the other, you need a common reference. For example, I change the reference now. For example, the same problem, let me change the reference. For example, this is minus 3 and this is minus 7, right? What if I add 10 volts to this point? Because I add 10 volts here, 10 volts. So what is minus 3 plus 10, right? So minus 3 plus 10 is 7, right? And minus 7 plus 10 is 3 volt. So minus 3 here and minus 7 here is good as 7 here and 3 here, right? Is good as 7 here and 3 here. Because what is the current ID? ID is still going to be 7 minus 3 by 1K. It is going to be how much? 4 milliampere, right? So that's exactly what we got here. So I've changed the reference by adding 10 volt, right? You can add 15 volt here and 15 volt here. You can add 20 volt and 20 volt here, right? So it doesn't change much. But the only thing we are interested is what is the difference between those two numbers on the integer scale. On the integer scale, you have minus 3 here and minus 7 here. The difference is going to be 4. Similarly, what's the difference between the 7 and 3 is going to be 4. So current always flows from a higher potential to lower potential, right? But please, when you're doing this, adding 10 or adding 5 or whatever, you have to be a little careful, right? Because every voltage you have to add, right? For example, some student after solving this problem, they just go and try the same thing with BJT. But you have to understand that BJT has 3 terminals. So if you're adding some voltage, it has to be all 3 terminals. Then only it's like you're pulling that circuit to a different reference. So your answers are not going to change, right? Okay. Now, find ID, if VD on is 0.7 volts. Find ID if VD on is 0.7 volts. Okay. So let us replace the diode with 0.7 volts. You have 0.7 volts with respect to ground. You can take some current I1, ID. You can apply KCL. Entering current equal to leaving current. Entering current equal to leaving current. What is I1? 5 minus 0.7 by 1K is ID plus 8 milliampere. So what is ID? 5 minus 0.7 is 4.3. 4.3 minus 8, it's minus 3.7. Now, can diode allow current in the opposite direction? No, is it not? You've seen the characteristic. You don't have a negative current. It's either the positive current or the negative voltage, but no negative current. Diode current cannot be negative. So is ID greater than 0? No. No, right? Therefore, diode is reverse bias. Reverse bias. If a diode is reverse bias, it means that ID is 0, right? ID equal to 0. The diode is reverse bias. And the current ID is 0, right? So I told you if ID is 0, then your VD should be negative. So let me check what is the voltage? I forgot. 5 volt with 1 kilo ohm. And here you have 2K and 8 milliampere. Now imagine there is no diode in this circuit. We have not connected. So the same 8 milli would have been flowing here, 8 milli. Then what is 5 minus 8? 5 minus 8 is going to be how many volt here? Minus 3 volt. Minus 3, right? So now I have a diode like this. Now tell me, the VD here, see that's the reason in the examiner always when he gives a problem, he says VD on. What do you mean by VD on? Take 0.7 only when it is on, right? So here the current ID is 0. The ID here is 0 because your VD is negative. Your VD is what? Negative. VD is nothing but minus 3 volt. Anode minus 3 minus 0, it's minus 3 volt. Your ID is 0. That means the diode has to be replaced by what switch? What's the equivalent for a diode now? The diode behavior is as good as an open switch. So this is our diode. This is our diode, right? This is our diode. And here we have 8 milli. The voltage here is minus 3 volt, right? So our assumption is false, right? We thought it was 0.7. If it is 0.7, the diode should sustain a positive current. If it fails, then replace the diode by open switch and calculate the voltage. If the voltage is negative, then the diode is reverse bias. So if ID is 0, if ID equal to 0, is VD less than 0? If ID equal to 0, is VD less than 0 or less than 0.7? True. True. Therefore, diode is reverse bias. Reverse bias. The diode is reverse bias because the diode cannot sustain a positive current. How is it minus 3? You can apply KVL here. KVL around the loop. Minus 5 plus 8 milli into 1K plus VD equal to 0. Plus VD equal to 0. VD is minus 5 plus 8 is 3. VD is minus 3. This is plus minus. So that VD, voltage VD happens to be negative, right? Therefore, the diode is reverse bias. If ID is 0, then VD should be less than 0.7 for diode reverse bias. For diode forward bias, if VD equal to 0, VD equal to 0 means replace diode by short circuit, and then the current flowing through the diode should be positive, right? So what is the definition of forward bias here? Forward bias. If the diode is replaced with short circuit, or in some cases 0.7 volts, then the current flowing through the diode should be positive. Should be positive. Should be positive. It means that anode is greater than what voltage? Cathode voltage. Then only the current is going to go from a higher potential to lower potential. What do you mean by reverse bias? Reverse bias. Right? If the diode is replaced with open circuit, then the voltage across a diode should be negative. Should be negative. This is an ideal case. If it is practical case, it means it should be less than 0.7 volts. Right? It should be less than 0, which is negative, or less than 0.7. Right? See, simple, if a diode is not forward, it is reverse. Are you getting? So suppose you are asked to check, you don't have to again check for reverse bias, not needed. Right? The moment he says check whether the diode is forward or not, if you check forward, if he fails, then automatically it is reverse bias, right? But if you replace the diode by open switch, definitely your VD is going to be less than 0 for ideal case, or it should be less than 0.7 volts from the characteristics. Okay. sketch the transfer characteristics. Sketch the transfer characteristics. A is diode ideal, or you can take VD on equal to 0.7 volts. So this is a very popular circuit, simple circuit, you all know. When I say transfer characteristic, what is the range of Vin? The range of Vin is going to be from minus infinity to plus infinity. Sketch the transfer characteristics. The diode is ideal, so in forward bias, ID is greater than 0 means your Vin by R is greater than 0 or Vin greater than 0. For all Vin greater than 0, the diode is forward. But what is the other case now for reverse? Vin should be less than 0. Whenever a diode is forward bias, replace the diode by short. Short. Your output follows input. If a diode is reverse bias, replace him by open switch. Output is 0. Right? Now, this is like y equal to mx. What is y equal to mx? It's a straight line passing through the origin with slope m equal to 1. And here this is y equal to constant or y equal to 0, which is nothing but x-axis, right? Y equal to 0 is x-axis. So how do you draw the transfer characteristics? You can take Vin on x-axis, V0 on y-axis. For all Vin greater than 0 during positive cycle, output follows input. Output follows input. Y equal to mx. If Vin is 1 volt, your V0 is also 1. If Vin is 5, your V naught is also 5. But if the diode is reverse bias, Y is 0, that means it is what axis? X axis here, right? V in less than 0. Now, what is the benefit of drawing the transfer characteristics? The benefit is, now whatever the waveform that he gives, any sort of waveform, suppose you have a triangular input or some input for that matter. If at all you want to sketch the output, this is V in. If at all you want to sketch the output, V naught, how do you sketch the output? For all V in greater than 0, output follows input. Output and input both are same. Output, input same. Output, input same. For all V in less than 0, your output is 0. For all V in less than 0, your output is 0 here. Or you can give a sine wave also for that matter. So if this is V in, what will be your V naught? For all V in greater than 0, output follows input. For all V in less than 0, this portion, your output is 0. So any name that we can suggest to this, what name shall we suggest, right? We can say that this circuit is half wave rectifier. Half wave rectifier. Half wave rectifier. The circuit is a half wave rectifier, right? Very, very popular circuit, half wave rectifier. So what do you mean by rectifier? Rectifier means a circuit that allows current only in one direction. One direction, right? So who is diode is a rectifier. Rectifier means a circuit that allows current only in one direction, or the device that allows current in one direction. So what about B bit? What if VD on is 0.7? What if VD on is 0.7? The diode is replaced with 0.7 volts. What is ID? Minus Vin plus 0.7 plus ID into R is 0. What is ID? Vin minus 0.7 by R. This is ID, right? Now we can have two cases: forward bias, reverse bias. ID is greater than 0 means your Vin minus 0.7 by R is greater than 0. It means your Vin should be greater than 0.7. If Vin is greater than 0.7, this Vin, yeah, 0.7 here. What is your output? Your output V naught, if you apply KVL, is Vin minus 0.7. So this is still Y equal to Mx plus C. So what is the slope M? The slope is still 1, but it is valid only for Vin greater than 0.7. In reverse bias, see, if a diode is not forward, it is reverse. For Vin less than 0.7, the diode is reverse. You can replace the diode by open switch, and your current ID is 0 here. Your V naught is 0. So Y equal to 0 means it is x-axis. So you have slope 1, you have x-axis, the same thing, but it is valid where? It is valid for Vin greater than 0.7. It's valid for Vin greater than 0.7. You have a slope 1. For Vin less than 0.7, you have x-axis. So this is the transfer characteristics. This is the transfer characteristics. So I asked you to sketch the transfer characteristic of a very popular circuit. As you all know, this is called a half-wave rectifier. So what happens if VD is 0.7 volts? Then the transfer characteristics looks like this, right? Now, as a homework, prove the transfer characteristic as shown. I'm giving you the transfer characteristic. You have to just prove it, right? If the diode is like this, you know. What if the diode is placed in a reverse fashion? If the diode is put in the reverse fashion, right? So D1, when is D1 on? D1 is on only when Vin is greater than 0.7. But when is D2 on? When is D2 on? D2 is not on till you provide, this is plus minus, so till you provide a voltage minus 0.7. But after that, your output always follows input. Once the device is on, we know what is the slope once the device is on, y equal to mx plus c, so you always have a slope 1. So there is you don't get any output between 0.7 and minus 0.7. So you can think about it, right? So if you have a transfer characteristics like this, yeah, this one. So till 0.7, the D1 is not on, right? So you get something like this. After that, the diode is off. But the D2 diode is going to get on for V in less than minus 0.7 volts. So between 0.7 and minus 0.7, between 0.7 and minus 0.7, there is this almost like what you call a similar characteristic for a push-pull amplifier you get. We call this as a dead band, right? There's no output, dead band in the sense, there's no output between plus 0.7 to minus 0.7, right? So you can think about this problem as a homework. Draw the transfer characteristics. The diode is treated as ideal. Now, is my voice audible? Is my voice audible? Please let me know. Is my voice audible? Thank you. So finally, we have come to know that a diode current is going to flow only from a higher potential to lower potential. Whenever you say the current flow to the diode is positive, that means the diode or current is flowing from a higher potential to the lower, right? So what if for, for a change, I just replace the diode here. I have a diode. What is the voltage at this point with respect to ground, and what is the voltage at this point with respect to ground? This node anode with respect to ground is at Vin, am I right? What is cathode here? What is cathode here? VC or VOC, the open circuited voltage, just open circuit, you will have 2 volt here, right? Your cathode voltage. So when is a diode forward? Case 1, diode forward bias. When is a diode forward? If anode voltage is greater than cathode voltage, it means that your Vin should be greater than 2. Am I right? If Vin is greater than 2, the diode is forward. That means the diode is replaced by what circuit? Short. If the diode is replaced by short, how does the circuit look like? It means that your output follows input. All right. Output follows input. Case 2, what happens when anode voltage is less than cathode voltage? When anode voltage is less than cathode voltage, that means when Vin is less than 2 volts. The diode is reverse bias. A reverse bias diode is replaced with open switch. In reverse bias, can current flow? No, the current is 0. 0 means no drop. So the total voltage V0 is going to be 2 volt. So now tell me, you either have Y equal to mx here, or you either have Y equal to constant. Y equal to constant is a straight line parallel to x-axis. And in Y equal to mx, what is the slope m? M is 1. So when you draw the transfer characteristic, you either have a line that is parallel to Y equal to constant. What is the constant value? Y equal to 2. So it's a straight line parallel to x-axis, right? So let me draw the transfer characteristics. Vn on x-axis, V0 on y-axis. For all Vn greater than 2 or less than 2, what is the output? Your V0 is always 2. Your V0 is always 2. Always 2. What happens when Vn is greater than 2? When Vn is greater than 2, you have a line with a slope 1, right? Have a line with a slope 1. So you either have a V0 of 2 or you either have V0 equal to V. So this is the transfer characteristics. Now, a similar problem here. Here we have anode potential. Here we have cathode. What is the voltage of anode there? The voltage of anode VA here is going to be Vin. But what is the open circuited voltage at this point? VC, right? So let me find it first. So sum of currents that leave a junction is 0. You can apply KCL. KCL. VOC minus 6 by 1K plus VOC minus of minus 6 by 2K equal to 0. Equal to 0. So what is VOC? So this is V0 minus 6. This is VOC, VOC plus 6. So you multiply by 2. 2 VOC minus 12. 6, 3. 12 by 6. It's 2, is it not? So your VOC is going to be again 2 volt. So this node is at 2, this is Vin. So what is first case? You have a diode where VOC is at 2 volts, the open circuited voltage, the anode is at Vin. Anode is at Vin. Now you tell me, if Vin anode voltage is greater than cathode voltage, or if your Vin is greater than 2 volt, the diode is what bias? Forward. If the diode is forward, replace the diode with short circuit. If you replace the diode by short circuit, then your output follows input. It's like Y equal to MX. What happens in second case if your Vin is less than 2? If your anode voltage is less than the cathode voltage, right? If your Vin is less than 2, the diode is open switch. If it is open switch, then because the diode is not on, there is the VOC still remains the same value. Your V0 is going to be VOC is going to be 2 volt. So as long as if Vin is greater than 2, your V0 equal to Vin. If Vin is less than 2 volt, if your Vin is less than 2 volt, if Vin is less than 2, then your V0 is going to be equal to 2. Equal to 2. So there's no difference between the previous problem and this problem. So in the previous problem, for this problem, the open circuit equivalent or the Thevenin equivalent will have a Thevenin voltage or the open circuited voltage equal to 2 volts there, right? So the transfer characteristics is going to remain same. The same characteristic. If you want, we can draw it here. So how do we draw this? We'll take Vin on x-axis, V0 on y-axis. How do you draw the characteristics? For all Vin less than 2, for all Vin less than 2, your V0 is 2. This is a portion less, right? Negative portion. For all Vin greater than 2, your output follows input with slope 1. So it's the same thing. Now, what if I have a triangular input or a sinusoidal input with a threshold voltage of 2 volts? Then how do you sketch V0? How do you sketch V0? For all Vn greater than 2, your output follows input. This line is 2. The portion above that line is called greater portion. The portion below that line is called lesser portion. For all Vn greater than 2, output follows input. For all Vn less than 2, your output, right? So the lower portion has got clipped and you're allowing only the upper portion. So these are all some sort of clippers, right? The lower portion which is below 2 volt is cut or clipped. Therefore, these circuits are called clipping circuits or clippers. Clipping circuits or clippers, right? Now to find VOC, you can apply KVL around this loop also, right? You can take, because only one loop is there, you can take one current and apply KVL also, right? Your wish. Or you can take entering current equal to leaving, or some of the current that leave a junction is 0, your wish. However you apply, your VOC is going to be 2 volt. In the comment section, students are asking, can we cut the upper portion, sir? Yes, we can cut any portion, right? The lower portion has been cut. We can cut the upper portion also, right? If you want to cut the upper portion, now because you want to cut the upper portion, let me, what happens if I put an extra resistor here? Sketch the transfer characteristics. The diode is ideal. Now, if I take this node as ground, then what is the voltage here? 0. With respect to this point, what is the cathode voltage and what is the anode voltage? So you can, so diode here. This point with respect to ground is 2 volt. Am I right? This voltage here, this voltage, you have V in here. There's a resistor R. What is this voltage? The anode voltage here. The anode voltage. This voltage is nothing but V in. Am I right? V in. So anode is at V in, cathode is at 2 volt. So what will happen first case? If anode is greater than cathode voltage or V in is greater than VOC, the open circuited voltage here, or V in greater than 2 volt, the diode is forward bias. If the diode is forward bias, we will replace the diode by short. Now tell me what will happen to output? Output is directly the 2 volts. So for all V in greater than 2, this time you want 2. Second case, the anode voltage, if it is less than the cathode voltage, or your V in is less than this voltage, VOC here, VOC, V in, right? The open circuited voltage is 2 volts. Then the diode is reverse bias. If the diode is reverse bias, we will replace the diode by open switch. Then what is the output? Output follows input. So the 2 volts has no connection now. If you replace by open switch, so there's nothing to do with 2. So now y equal to constant. It's a straight line parallel to x-axis. And now y equal to mx, your slope m is 1. So how do you draw the transfer characteristics now? Right? Now you said that for all V in less than 2, you want the slope 1. You want the slope 1. For all V in greater than 2, your output is 2, right? So this is the transfer characteristic. And what will be the waveform? And what will be the waveform? For all V in less than 2, output follows input. For all V in greater than 2, your output is 2. So as you wished, the upper portion has got clipped. We've got only the lower portion. And this is the transfer characteristic. Now, do you think in this case, the open circuited voltage here is still going to be Vin, is still going to be Vin when you, and what is the voltage at this point? There's a voltage source, you have two, but what is VOC? VOC, if you open circuit the diode, this VOC by voltage division is nothing but the voltage across R here. So VOC is nothing but Vin by 2. And why half? Because it's a voltage across this resistor. Now this, the voltage across this resistor is applied to a diode, and the diode other end has 2 volt. And the diode non-inverting is Vin by 2, and the inverting is I'm still in op-amp. The anode is at Vin by 2, and the cathode is at what? 2 volts, right? Okay. So as long as VOC is greater than 2, the diode is forward. The diode is forward. Who is VOC? Vin by 2 is greater than 2, or Vin greater than 4. So this time it's not 2, because what happens when Vin is 3? So this is interesting, right? What happens if Vin is 3? You have R and R, so your VOC is going to be 1.5. With 1.5 at anode and 2 volt at cathode, the diode is reverse biased. So you have to wait till 4 plus. When Vin is 4, because of the voltage divider, you have 2 volt here. When VOC goes 2 plus, that is when the diode gets forward bias. So once the diode is forward, then after that, the output is restricted to this 2 volts, because we know in a parallel connection, the voltage remains same. And what happens if Vin keeps on increasing? The extra voltage will be dropped across this, the series resistance R, this resistance. But this R will always be having 2 volt across it once the diode is on, right? What happens if VOC is less than 2 volt? The open circuited voltage here is less than 2, or Vin by 2 is less than 2, or Vin is less than 4. The diode is reverse bias. A reverse bias diode is replaced with open switch. Then your V0 is going to be Vin by 2. Okay. Now, for the first time, we have y equal to mx, but the slope m is 0.5. The slope m is what? 0.5. But here, your y equal to constant, it is still a straight line parallel to what axis? So m is 0.5, right? So it's a straight line parallel to x-axis now. This is a straight line. Vn on x-axis, V0 on y-axis. So just tell me, for all Vn less than 4, your Vn should be less than 4, then your V0 is going to be Vn by 2. If Vn is greater than 4, then if Vn is greater than 4, your V0 is going to be 2 volt. So if Vn is greater than 4, your V0 is going to be 2 volt. Vn is greater than 4, your V0 is going to be 2. Let me change the color of the pen. If Vn is less than 4, you're going to have a slope of 0.5. So when Vn is 2, you're going to have only 1 here, right? Slope is. And why did the slope become 0.5? Because of the voltage division. So the demand on Vin has increased now. If Vin is 6, the diode anode is only 3. If Vin is 10, the diode anode is only 5. If Vin is 15, the diode anode is only 7.5. So as Vin keeps on increasing, the VOC value is changing because of the voltage division. So that is the reason when you connect a diode, your Vin should be at least 4 volt plus, so that your V anode is going to be 2 volt plus. That is when the diode is on. Your output is always restricted to 2 volts, right? See, it seems in all the problems I'm taking 2, 2, 2, not taken -2. I'll reverse the diode also. Sketch the transfer characteristics. The diode is ideal. Now, what is the voltage at anode here? Here, what is the anode voltage? This voltage at anode is going to be -2, but the open circuited voltage here is going to be this voltage. If you open circuit the diode, it's going to be Vin. So now be careful here. Vn is not at anode, it is at cathode. But we know that when is a diode forward bias? Diode is forward bias if your anode voltage is greater than cathode voltage. Your anode voltage should be greater than cathode voltage. So this is your anode voltage and this is your cathode voltage. right? So anode should be greater than cathode. Anode should be greater than cathode. That means your Vin should be less than -2, right? Diode is forward bias if anode is greater than cathode. So once it is forward bias, it is replaced by what switch? Short circuit. Then what is V0? What is V0? If you want, you can apply KVL. Plus to minus, +2 plus V0 equal to 0, KVL. Your V0 is going to be -2 volt. So your V0 is -2. What happens if anode is less than cathode voltage? Anode is less than cathode. Anode is -2, less than cathode. That means your Vin is greater than -2. Then the diode is reverse bias. The diode is reverse bias because the anode is less than cathode. So we will replace the diode with what switch? Open switch. So what's your V0? V0 is going to be V. So look at the final result and draw the transfer characteristics. Draw the transfer characteristics by looking at this final result. For all Vin less than -2, your output is -2. For all Vin greater than -2, your output follows input. So here we have -2, right? For all Vin less than -2, your output is -2. So it is less, your output is -2. For all Vin greater than -2, for all Vin greater than -2, what is happening when Vin output follows input with slope 1? So this is the transfer characteristics. What if we give a triangular input? Then how will you sketch the output? For all Vin, you can see for all Vin less than -2, output input are same. Output input are same for all Vin less than -2. So this dotted line is -2. Anything comes down is called less. Anything above is greater. For all Vin greater than -2, output for, what did I do? For all Vin less than -2, your output is how much? -2. So I made a mistake here. So you can see for all Vin less than -2, your output is -2. For all Vin greater than -2, your output follows input. Output follows input. For all Vin less than -2, it is -2. Or you can take a sinusoidal waveform. So you're going to get for all Vin greater than -2, output follows input. For all Vin less than -2, output is going to be -2. So this is going to be the waveform. So like this, you can have any number of combinations, both in the series arm as well as the shunt arm, right? I think in all the problems, I have not taken zero point 0.7 volts, right? I only took diode ideal, ideal, ideal. See, for calculating VOC means open circuit. You just remove the diode and draw. When you remove the diode, will current flow? No, it's easy for you to know the anode and cathode voltage. I mean, those nodes, when there is no diode, you can name node 1 at anode and node 2 at cathode, right? So you just remove the diode, anode voltage node 1, cathode voltage node 2. So 1 and 2, you can take it as VOC1, VOC2 like that, right? Just remove the diode, and whatever the node the diode was there before removing, you can calculate them as anode and cathode. So you can see here. So you have a diode, just remove the diode. When you remove the diode, what is the voltage here at anode or at this point? It is -2. And the voltage at this point is Vin, because the circuit looks like this, right? 2 volt is this point, which is anode. And this is cathode, right? So this is Vin. Cathode is Vin, anode is how much? -2. Now you can connect the diode. When you connect the diode, if anode is more positive than cathode, then only the diode is forward bias. If anode is less positive than cathode, the diode is reverse bias. So now you can see here, when a diode is there, anode voltage is at -2 volts and the cathode voltage is at Vin. So if -2 is greater than Vin, then the diode is forward. Otherwise, the diode is reverse, right? See, if you don't want to open circuit, what you can do? You can replace the diode by short and calculate the current. Because I told you by definition, what is the definition I told you? A diode is forward bias. A diode is forward bias when, a diode is forward bias when anode is more positive than cathode. Did I tell you that? Yeah. You can see that a diode is forward bias when anode is more positive than cathode. So you can remove the diode at that point, anode and cathode, you can calculate. So this is simple if you have a single diode circuit. Or if you want to calculate the current, it's your wish. You can short it. For calculating the current, one extra step, right? You have to replace the diode by short and apply KVL. The same answer you're going to get, however, right? So please don't forget that diode is on only when anode is more positive than what? Cathode, right? Anode should be more positive than cathode. That is when the diode is forward bias. So where is this circuit now? This one, yeah. Yeah. Now we have to calculate this. Now, if you, this is the first circuit that I've given, half-wave rectifier. But the only thing is, in the half-wave rectifier, here we had Vin. This Vx was Vin, right? So if you want, you can apply KVL around the loop. So what is KVL in this small chota loop here? Minus Vin plus 2 plus Vx is 0. So what is Vx? It is Vin minus 2. Vx is Vin minus 2. So if you want, you can calculate by the same procedure, Vin minus 2 and ground, or this is a basic diode circuit that I've given, the first circuit, half-wave rectifier. Oh, I know how to handle this now. Yes, so this is Vx, which this Vx is nothing but Vin minus 2. Am I right? So when no sources are there, when you open circuit, this end is at 0, this end is at Vin minus 2. So what is first case? If Vin minus 2 is greater than 0 or Vin greater than 2 volt, the diode is forward bias. The diode is forward bias. And the diode is forward bias, replace the diode by short. You have Vx here. Your V0 is going to be Vx, or your V0 is going to be Vin minus 2. So what is the slope M? It is still 1. Case 2, if V in minus 2 is less than 0, if V in minus 2 is less than 0 or V in less than 2, the diode is reverse bias. A reverse bias diode is replaced by open switch. So your current is 0 in open circuit. Your output is also 0. So what do you mean by output 0 or x equal to 0? This is nothing but y-axis. So you have a slope 1 only for V in greater than how many volts? 2 volts. For V in greater than 2, you have slope 1. For V in less than 2, you have y-axis. You have y-axis for V in less than 2. V in greater than 2, you have a slope 1. So this is the transfer characteristics of this circuit, right? Why did this come? Some mirror image has come. So diode problems, the more you practice, it's better for you, right? Because I don't know when you look at the circuit, what doubts you have, right? Some of the doubts I've tried to clarify in my introduction. I said, in an open circuit, you have the whole voltage V, but the current is 0. In a short circuit, you have voltage 0, and the current is going to be some V by R in that loop. So same thing, it's only that fundamentals now. Open circuit, you're going to get that whole voltage manifested there. So if I open circuit the diode, this Vx is going to be V in minus 2, and the cathode is connected to ground here, right? This is anode voltage, and the cathode is connected to ground through the resistor, right? So when you open circuit, no current, anode is greater than cathode, you can calculate, right? See, for drawing a straight line, you need 2 points, right? To draw a straight line, you need 2 points. If you have not understood drawing a straight line, drawing the transfer characteristic, at least take 2 points. At least you should know two values which are greater than 2. Suppose Vn is greater than 2. Do you know any value greater than 2? 3 or 4, 5. These are all values greater than 2. And you should know how to locate them, right? So when Vn is greater than 2, 3, 4, 5 like that, your output is equal to Vn minus 2. So when Vn is 3, your V0 is 1. When Vn is 4, your V0 is 2. If you locate, you can draw a line, right? So to draw a straight line, the fundamentals, right? You've studied that in your 8th standard, right? So a line is always characterized by 2 points. You need 2 points on a graph. So some students who are not able to draw the graph, locate 2 points. That is enough. If I say V in less than 2, you have to think what are less than 2. V in less than 2. 1 is less than 2. 0 is less than 2, right? Or minus 1 is less than. Take those values. For V in less than 2, your V0 is 0. So 0, right? Minus 1 comma 0 or 1 comma 0, 0 comma 0, minus 1 comma 0. You just take those points and draw a line. 2 points are enough to draw a line. Are you getting, right? So if you're not able to draw the transfer characteristic, remember, if you want to draw a line, you need 2 points. You need some 2 points on the graph. Okay, so the cathode is at ground here. If you open circuit, what is this open circuited voltage here? If you open circuit the diode, what is VOC here? So this voltage with respect to ground, VOC is going to be V in R2 by R1 plus R2. Right? And what is cathode voltage here? The cathode voltage, this is cathode voltage. It's at ground, right? The cathode voltage is at ground, your VOC, right? Now for the diode to get on, your VOC should be greater than 0.7, please. You should not say greater than 0. You should not say any positive value, greater than 0. Now, if this is not an ideal diode, the diode needs a drop of 0.7. So your VOC, if it is greater than 0.7, if suppose VOC is 0.5, the diode is off. If VOC is 0.6, the diode is off. If VOC is 0.69, the diode is off. If VOC is 0.71 or 0.7 above, the diode gets a bang, right? So if VOC is greater than 0.7, the diode is if VOC is greater than 0.7, what's happening? What is this? If VOC is greater than 0.7, the diode is forward bias. Am I right? What is VOC? V in R2 by R1 plus R2 is greater than 0.7, or V in is greater than 0.7 into 1 plus R1 by R2. If V in is greater than 0.7 into 1 plus R1 by R2. So as a simple example, what if R1 is 1K and R2 is 1K? If R1 is 1K and R2 is 1K, if both are 1K and 1K, it's going to be 1.4. So if V in is 1.4, 1K, 1K, that is when you get 0.7 here because of voltage division, right? So if V in is 5 volt, you're going to get 2.5. If V in is 1.4, you're going to get 0.7, right? So if V in is greater than 0.7 into 1 plus R1 by R2, the diode is forward bias. When the diode is forward bias, the diode is replaced by how many volts? The diode is on. It is going to give you 0.7 volts. What happens in the second case? If VOC is less than 0.7, the diode is reverse bias. VOC less than 0.7, or your V in is less than 0.7 into 1 plus R1 by R2. If the diode is reverse bias, then what is your V naught? The diode is reverse open switch. Your V naught is going to be the same VOC. Your V naught is going to be VOC, which is V in R2 by R1 plus R2. So you either have 0.7 volts or you either have a slope M equal to R2 by R1 plus R2. You either have a slope M equal to R2 by R1 plus R2. So what is the transition here when V in is greater than 1.4 or 0.7 plus 1 plus R1 by R2, your output is restricted to how much? 0.7. If it is greater, it's going to be how much? 0.7. What happens if it is less than this value? Then you will have a slope of R2 by R1 plus R2. You have a slope of R2 by R1 plus R2. So this is the transfer characteristic. Okay, shall we have a break now? When we come back, we will do this problem. And in the comment section, I found students asking me, what will happen to the drop, right? So most of the students, they have this doubt that what will happen to the drop here. So why you're not considering the IR drop? See here, there's something like a diode always takes how many volts? 0.7. It does not take anything more than 0.7, right? It's only 0.7. Now, suppose if I give you 0.7001, I give you 0.7001. How much does the diode take? 0.7. Whatever is left, 0.0001 volt is dropped across the resistor here. So this is a voltage across the resistor. Are you getting? Suppose if I give 12 volt, what will happen? The diode will still take 0.7 and the leftover 11.3 volts is dropped here across the resistor. So don't worry about the drop. See if the voltage is greater than how much? 0.7 or not. That is the only thing you have to say. The reason is, see, it's almost like, I remember generally in what you say. See, as a simple analogy, the resistor is, I don't know. The resistor is, see, I don't know how to, what analogy can we take? Yeah, suppose there's a family and you have a mother who's serving food to everyone, right? So the resistor is like the mother. She feeds the voltages to every diode and every BJT, and whatever is left he takes. It's not that he takes first and there's no voltage for the diode. No, if it's 0.70001, there are mothers who don't eat sometimes, and sometimes they are eating all the leftovers. So that then, see, it's the duty of men to invite them to have food together, right? Otherwise, mothers, what they do, they just feed everyone and finally they have food. So that's very bad, right? So they should have food together, right? So the olden days, mothers are like that. So it's like on some day there's not much food, like 0.7001. Now these guys, the diode and the BJT, they are all on diet. They take only 0.7. They have a fixed amount of food. They have it. But what if there's no food? Your 0.7001, the leftover is taken here, 0.00001 to the resistor. Some days there's more food. So 12 volts, the diode still takes 0.7. It's 11.3 there. Are you getting? So don't worry about the resistor. The resistor is there only to satisfy Kirchhoff's law. The resistor is not there to demand any drop. Resistor will never demand any drop. It only sees that the algebraic sum of voltages in a loop is 0. Your job is only to see if that voltage is slightly more than 0.7. That's it. Sir, I have a voltage that is 0.7 plus. Your diode is on. Your diode is on, right? So don't worry about the IR drop of the diode, right? So we'll take a break now. When we come back, we will solve circuits, right? Thank you. Okay, can you hear me? Can you hear me? Yeah. Now, how do we solve this? We have V in and two resistors in series. And here there is a diode. All right. So what is VOC here? VOC is still V in. This is your VOC. Right. So as long as case 1, VOC is greater than 0.7, diode is forward bias. Or your V in should be greater than 0.7 volts, right? Your V in should be greater than 0.7. But if the diode is forward bias, once the diode is forward, what is V naught? What is V naught? This time V naught is not 0.7. There's some current I. V naught is I into R2 plus 0.7. What is I in this loop? It is V in minus 0.7 by R1 plus R2 into R2 plus 0.7. So what is the slope M? The slope M is V naught is Y equal to Mx. Who is X here? Who is X? X is V in. So what is the factor that is associated with V in? It is R2 by R1 plus R2 is a factor associated with V in. So the slope is R2 by R1 plus R2 for V in greater than 0.7. What happens if VOC is less than 0.7 or your V in is less than 0.7? The diode is reverse bias. A reverse bias diode is replaced by open switch. No current will flow. So your output is going to follow input in this case. Your output is going to follow input. For all V in greater than 0.7, you have a slope M. You have a slope M equal to R2 by R1 plus R2. And what is the slope here? It is going to be 1. So slope M R2 by R1 plus R2 and slope 1. But when is slope 1 for V in less than for V in so for V in less than 0.7, your output follows input with slope 1. For V in greater than 0.7, for V in greater than 0.7, you have a slope Y equal to Mx. X is V in, it's R2 by R1 plus R2. So you're going to have a slope of R2 by R1 plus R2 for V in greater than 0.7 volts. So this is the transfer characteristics. Now, what if R2 and R1 are same value? If R2 and R1 are same value, then for all V in less than 0.7 volts, you're going to have output equal to input. But for all V in greater than 0.7, you're going to have half of the signal, right? So the slope is 0.5. The slope is going to be 0.5. So after drawing the transfer characteristics for single diode problems, find I comma V naught. The diode is ideal. Okay. Now, how do we solve this problem? If you apply the same technique, the VOC technique, anode of first diode is at 1, anode of second diode is at 2, anode of third diode is at 3, but cathodes are tied together and given at 1K. If anode voltage is at 1 volt here and cathode is tied to ground, what is the nature of D1? If anode is at 2 and cathode is tied to ground, what is the nature of D2? Anode is here, cathode is tied here. What is the nature of D3? Right. The first impression a student gets is maybe all the 3 diodes are on, right? Because anode is at. But what happens if all the 3 diodes are on? If all the 3 diodes are on, you will be violating Kirchhoff's law. Why is it violating Kirchhoff's law here? At any point, there can be only one potential. But if you say that this node is at 0, it's at 1, so this should be at 1, 1, 1, 1, 1, but how can it be 2? If you say it's 2, then how can it be 3? So at any given node, there can be only one potential. So if you think that all the 3 diodes are on, that is violation. But which diode is on such that the other 2 diodes are off, so that we don't violate Kirchhoff's law, right? Because this can never happen. At any given point, there can be only one potential, right? So now, what if 1 is on, D1 is on? If D1 is on, then this voltage V0 is also at 1 volt. So you have 2 and you have 1 here. So the diode is again forward. So it's not possible. If D2 is on, then D3 is also on, right? So in my opinion, out of the 3 diodes, the diode that experiences more potential difference will switch on. More potential difference will switch on. So who is that? D3. Because if D3 is on, this voltage is going to be 3. If this voltage is 3 here, then if D3 is on and the diode is a short circuit, this node V0 is going to be 3. But when it is 3, you have 2 here. 2 minus 3 is negative. D2 is reverse bias. 1 minus 3 is also negative. Anode minus cathode voltage should always be positive, right? Anode should be at higher potential than cathode. So if D3 is on, then definitely D2 and D1 are going to be what bias? Reverse bias, right? So this is how we don't violate Kirchhoff's law. Otherwise, if you think that D2 is on first, then D2 and D3 should be on. If you say D1 is on, all the 3 on, so that is all the 3 getting on, and this voltage is 1, 2, 3, this is wrong, right? Out of the 3 diodes, the diode that experiences more potential difference will switch on. So your V0 is going to be 3. And what is I? I is going to be V0 minus 0 by 1K. V0 is 3, 3 by 1K, it is 3 milliampere. So your current is going to be 3 milliampere, your output is going to be 3 volts, right? So if this circuit has to exist, then D3 has to be on. See, why at a given point 2 potentials cannot exist? For example, if I intentionally connect, suppose if I take a battery of 6 volts and I connect it to 4 volt and I don't put anything here, any resistor, and just short, then what is the current I here? The current I, because at this node you don't know whether it's 6 or 4. The current I is going to be 6 minus 4 by 0, infinite current will flow. So slowly smoke will come from circuit, right? So this circuit is not going to exist, right? It's going to get spoiled if you just take 2 batteries of different values and short them, right? But what if you take 2 batteries of same value? If you take 2 batteries of same value, what will happen if you take 2 batteries of same value? Suppose if I have a battery of 1 volt and then another 1 volt here battery, 2 batteries in parallel. And if I connect 1 ohm, what is the difference between this circuit and this circuit? What is the difference between this circuit and this circuit? Is there any change in the current I here? The current I is going to be 1 by 1, it is 1 ampere. 1 volt by 1 ohm, it is 1 ampere. Here also the current is going to be 1 ampere, right? Now, the other day, we have an inverter in our house, and the other day we want to increase the load, right? So I said, I want to increase the load. So I called up the inverter guy. He did nothing. He just came with an extra battery and connected in parallel. So why is he connecting in parallel? You might think that the current is only 1 ampere, but what is the current given by each battery now? Each battery is now going to give only 0.5 ampere. 0.5 ampere, this is going to give you 0.5 ampere. The total current is going to be 1. This is called load sharing, right? So it's called load sharing. So now, suppose I have a battery which will maximum give only 1 ampere of current, right? Now it is giving 0.5. That means I can increase the load now. I can increase the load. Now this can maximum give 1 ampere. So the whole 1 ampere is here. That's it. But for the upper one, I can probably connect an extra load here, 2 1 ohm resistors, because all our appliances in our house are in parallel. Now what will happen if this is 1 ohm and 1 ohm and 1 volt and 1 volt? You have 1 ampere here and 1 ampere here, and each battery is going to supply a current of 1 ampere. So this is called load sharing. When you connect batteries in parallel, then it allows you to have an extra resistors in parallel, right? Otherwise, if you say that, no, I don't want to switch on fan, tube light, everything, TV, everything, right? Then you switch it off. When you switch it off and you have only 1 fan like this, only 1 ohm, only 1 load, then each battery is going to give less current, right? But if you have more load, then definitely more current. But what happens if the same 1 ohm is connected in parallel here? If you connect the same 1 ohm in parallel, then 1 ohm parallel with 1 ohm here, if you connect 1 ohm in parallel here to the 1 volt battery, then this has to give 2 amps and the battery is gone, right? The battery is gone, because I told you the battery can maximum give only a current of what? 1 ampere. So it can't give 2 amperes of current. So whenever you want to increase the load, see that you increase batteries also, right? So load sharing. So I told him, now I have fans and tube lights working, but I want TV to work, I want mixing, everything, right? So then he just came with an extra battery connected in parallel and he left. He said, now you connect the load. When you connect the load, the current that these loads are shared by 2 batteries now, right? Okay, right? Now, why am I saying this is, suppose if 3 volt, 3 volt, 3 volt is given to a diode, right? 3 diodes. Then there is no partiality. There's no partiality. All the 3 diodes are going to get on naturally. When all the diodes are on, there's load sharing. Your V naught is going to be 3 volt now. This is 3K. Now, what is the total current I total? The total current going to the load here is 3 by 3K. It's going to be 1 milli. Now, do you think every battery is giving 1 milli now? This I total, and this is I here, this is I, this should also be I, this should also be I. So if you apply Kirchhoff's law, I total is going to be 3I. I total is going to be 3I, or I is going to be I total by 3, which is 1 milliampere by 3. It's going to be 0.333 milliampere, 1/3. So each diode is going to share a current of how much? I is going to be only 0.33, but the total current that is flowing to the load is 1 ampere, right? It's called load sharing. When you have more batteries in parallel, this is the advantage now, right? Now, what about this problem here? The open circuited voltage at this point here, if you just remove the diodes, you're going to have 5. Now, 5 minus 1, 5 minus 2, and 5 minus 3. So out of the 3 diodes, which diode experiences more potential difference? So which number is larger, 5 minus 1 or 5 minus 2 or 5 minus 3? Naturally 5 minus 1, right? 5 minus 1 is 4. So out of the 3 diodes, which diode experiences more potential difference? Out of the 3 diodes, D1 experiences more potential difference. So now D1 is going to be on. So you have 1 volt here. So your V naught is 1, right? Because if D1 is on, we replace D1 by short. But what about the other 2 diodes? If this is 1 and cathode is at 2, D2 is going to get reverse bias. D3 will also get reverse bias because of 3 volts at cathode. And here you have a PK. And of course, 5 means it's 5 with respect to ground. So current always flows from a higher potential to lower potential, right? So the current, like in this fashion, through D1. So what is the current I? You can apply KVL. Minus 5 plus I into 3K plus 1 is 0. I is, what is I? 5 minus 1 by 3K. It is 4 by 3 milliampere. Four by 3 milliampere. So who is going to get on? Only D1. Only D1. So D2 and D3 are reverse bias. Are you able to hear my voice? Is it audible? Is it audible? So why D1 is experiencing more difference here? The anode of D1, anode of D2, anode of D3 are same. That is X, some voltage X. X minus 1 is anode minus cathode, X minus 2, X minus 3. Out of the three diodes, which number is larger? Suppose this is X voltage, right? X minus 1 or X minus 2 or X minus 3. Naturally, X minus 1, right? So D1 experiences more potential difference, it is switched on. When it is on, your output is restricted to 1 volt, right? This is figure 1 and figure 2 and figure 3, right? So let's see figure 1. Figure 1, we have a diode here. We can replace the diode with short. If you want to check, this is 10 volt. This node is at minus 10. One K and 2K, right? So what is ID1? ID1 is going to be 10 minus of minus 10 by 1K plus 2K. It is 20 by 3 milliampere positive. Therefore, D1 is forward bias. Therefore, D1 is forward bias, right? Or the same diagram, you can draw it like this. This is 10 volts. 1 kilo ohm. We have a diode here. Then 2K. And then you have minus 10. Right? And then you can apply KVL, ID1. So you get the same answer, right? Minus 10 plus ID1 into 1K plus ID1 into 2K minus 10 volt equal to 0. Your ID1 is going to be 20 by 3 milliampere. So once the diode is on, what is V0 here? What is V0? V0 is a voltage at this point, anode here. So ID1 can also be said as 10 minus drop, is it not? So what is V0? It is 10 minus ID1 into 1K. It is 10 minus 20 by 3 milliampere into 1K. So 6.66, it's 3.33 volt. So your V0 is going to be 3.33. So V0 is 10 minus ID1 into 1K. You can apply KVL, right? So you can apply KVL. So V0 is 3.33 in this, but what did we do in figure 2? This is figure 1. In figure 2, we said that if D1 is on, what about the nature of D2? And this node is at 3.33 volt. So this is also at 3.33. What about D2? What about D2? So anode is at ground and cathode is at 3.33. So D2 is going to be off. So figure 2 says that D1 on, D2 off, your V0 is going to be 3.33 volt. But what is figure 3? Figure 3 says that if D1 is on, and you have a diode in this fashion. All right. What is figure 3? Oh. Figure 2 has anode here. As anode. This is figure 2. Figure 2, this is figure 3. Right. Figure 2 says that this is 3.33 volt. So now you have an anode here. So D2 is also going to get on. If D2 is on and D1 is also on, what is the circuit? So your V0 is going to be, directly this end is grounded. So your V0 is going to be 0 volt. 0 volt. See, carefully see how the behavior of the circuit changes. In the first problem, all of you, in the first problem, let me show you step by step. In the first problem, I didn't connect D1. When I didn't connect D1, suppose this is D1, I didn't connect this node and this node. If you see, this is plus 10 and this is minus 10. Okay, this is plus 10 and this is minus 10. When you didn't connect D1 in figure 1, what happens when D1 is connected? When D1 is connected, the moment D1 is connected, the two different circuits became one. The two different circuits became one. There's a connectivity now. Once the D1 is on, this node and this node are same. They became 3.33 volt. And 3.33 volt is somewhere between plus 10 and what? Minus 10. Now give me the numbers between plus 10 and minus 10. Between minus 10 and plus 10, you can have minus 9, minus 8, minus 7, minus 3, minus 3.33, 4, minus 4, like that, right? Minus 3, minus 2, 0, 1, 2, 3, 4, 5, everything. There's any value between minus 10 and plus 10. But remember, between minus 10 and plus 10, you have 0 volt also. So this is something we have seen in figure B, right? The circuit, the figure A, right? Figure A after diode is connected. Diode D1 is connected, right? Now, in the previous diagram, what happened in figure 2? In figure 2, this is figure 1. Figure 1. What happened in figure 2? In figure 2, after another diode is on, again the whole pattern changes. You had 3.33 here, and suddenly this diode is on now, right? This guy is on. When this guy is on, then this node is neither plus 10 nor minus 10 nor 3.33. The new voltage is going to be 0 volt. The new voltage is going to be 0 volt. So let me repeat that here. You can see here. Yeah. This is the solution for figure 2, figure 3. This is the solution for figure 2. And this is the solution for figure 1. Figure 1, right? So this is just a rough work, right? So this is just a rough sketch. How do you spell rough? Okay. Rough, R-O-U-G-H. So just an explanation. So when you didn't connect any diodes, so you had plus 10 and minus 10 initially, and then the first diode D1 comes into picture. It became 3.33, and then D2. When D2 is on and D1 is also on, the voltage has become 0 volts, right? Okay. But when D2 is off, only D1 is on, it is still 3.33. When D1 is on and D2 is also on, so your voltage became 0, right? So now finally, if no diodes are connected, plus 10 up and minus 10 down, first diode is on 3.33, first diode and the second diode is on, your voltage is going to be 0 volts, right? So it's going to be 0. Okay. Now I want you to do the same problem. I want you to draw the same circuit, but interchange 1K and 2K, right? So it's just fun. If you just interchange the resistors 1K and 2K, just swap them. Let the 2K go up and the 1K come down. Interchange the resistors. Interchange the resistors. Let's see what happens if you interchange them. So in the previous examples, we had 1K up. Now we want 2K up, right? So just interchange 2K here and 1K here. What happens if you interchange 1K and 2K? The first circuit, replace the diode by short circuit here, plus 10 and minus 10. This time you have 2K up, right? 2K and 1K. So what is ID1? ID1 still remains same. The current is same. By interchanging, it's just simply a series circuit. So the current will still remain same. 10 minus of minus 10 by 2K plus 1K. 20 by 3 milliampere. But what changes is V naught. What changes is V naught. Tell me what is V naught? It is 10 minus ID into 2K. It is 10 minus 20/3 milliampere into 2K. So how much is this? 6.66 into 2, 10 minus of that value. So it's 30 minus 40 minus 10/3. It is minus 3.33 volt. So we got the same voltage, but minus 3.33. And it's valid also because between minus 10 and plus 10, between minus 10 and plus 10, you have V0. And V0 can be anywhere between minus 10 and plus 10. So minus 3.33 is still valid, right? D1 is still forward bias because the current is positive. Whenever the diode sustains a positive current, it is on, right? No problem. Now tell me, what about figure 2? Figure 2. If this diode is on, but it gives a negative voltage now, minus 3.33. What happens when I connect D2? Figure B, yeah, D2, like this. D2. So it says that once this diode D1 is on, then D2 can also be on. If D2 is on and D1 is on, then the new voltage that is going to lie is going to be 0 volt. But what about figure 3? Figure 3 says that if D1 is on, and you have the second diode in this fashion, here you have minus 3.33, and that is D2. So what is the nature of D2 now? The nature of D2 is D2 is going to get on now, right? In the previous case, what am I doing? Minus 3.33 is connected to anode, so this is closed switch or open switch. It's an open switch. The diode is off, not on, off. So what is your V0? Your V0 is still going to be minus 3.33, right? I'm sorry, right? I don't know what I'm thinking. Yeah, when negative is connected to cathode, naturally the diode is on. So what is the equivalent now? The equivalent says that your V0 is going to be 0 volt, right? So in this case, the diode cannot be on. Anode is connected to minus 3.33, so diode D2 is off in figure 2, right? In figure 3, your V0 is 0, right? So did you get the same answers? Your V0 is minus 3.33. Good. So some of you have questioned me saying that how D2 is on in figure 2. You're right. D2 is off. I made a mistake here. I stand corrected. D2 is off. Your V0 is going to be minus 3.33 volt. And D2 is on in figure 3, so your V0 is 0, right? Now, for the last time, what if we interchange only D1? That's more fun, right? You just interchange only D1 and see how the voltages, the pattern changes. So in this circuit, I want you to interchange only D1. So the D1, you just flip anode to cathode and cathode to anode, just flip it and see how the pattern changes. So when multiple diode problems are given, I tell you, you have to make an intelligent guess, right? So as to whom to start. Should I start with D1 first? Yes, because D1 has plus 10 and minus 10. So it experiences more potential difference. So you can always start with D1, check for D1, and then you can go and check for D2. Or you can replace both diodes by what circuit? Short circuit. Take the currents. If the currents are positive, then the diode is forward bias. You can also do like that. I will do with currents also. Find V01, V02. So the same problem, why don't we repeat it, right? The same problem, let's repeat it. But we have to interchange whom? Only D1. This is figure 1. Always choose a diode with more potential difference. So that's not a rule. You can go with any diode, or you can go with 2 diodes also, right? So I'll do with 2 diodes also. Now we are taking one diode at a time, and we are coming to that conclusion. What if we take both the diodes into consideration? Then also we can get the answer. So we can replace diodes by short circuit and take a current. If the current is positive, please, whenever you're taking a current through diode, always take the direction from anode to cathode, right? You take from anode to cathode, then the diode is forward bias. Now tell me, I think I don't have to check the first one. Cathode is connected to 10 and anode is connected to minus 10. Do we have to check the first one? Cathode is connected to 10 and anode is connected to minus 10. So it is understood that the first one, this diode is what? Okay, even if you replace it by short and take a current from anode to cathode, the current will be negative. You take a current ID1, then this is plus 10 and minus 10. So what is ID1? ID1 equal to minus 10 minus of plus 10 by some resistors, 2K plus 1K. Negative. Diode D1 is what bias? Reverse bias. If a diode D1 is reverse, you open circuit, then what is V01? V01 is going to be 10 minus drop. So what is the current now? The current flowing through the diode here is going to be 0, right? So when the current is 0, your V01 is going to be plus 10. It's 10 minus drop, but there's no drop here. Resistor has no drop, 0 drop, 0 drop, right? So no drop. So similarly, minus 10, V02 is going to be minus 10 volts. V01 is going to be plus 10, V02 is going to be minus 10, right? And the simple logic is anode is connected to minus and cathode is connected to plus. In the first diagram, anode is connected to minus cathode. So naturally the diode is what bias? Reverse bias, right? Anode if it is plus, cathode if it is minus, then it's okay. So anode is negative, but cathode is positive. Definitely the diode is reverse bias. So the diode is reverse bias in figure 1. Your V01 is 10, but V02 is minus 10. So now you understand if D1 is off, what about D2? What about D2? There's minus 10 here. Plus 10, minus 10. Let me see the diode direction. Anode is connected. So here you have anode. So this diode is also off. If this diode is off, what is the equivalent now? Here you have open switch, here also you have open switch. So if this is plus 10, V01, V02 is minus 10. All right, this is figure B or figure 2. Figure 1 says V01 is 10, V02 is minus 10. It's the same thing. But what about figure 3? Figure 3 says that if D1 is off, and here you have V01 is 10, and V02 is minus 10. Here there is a diode that is connected in this fashion, D2. So what about D2? D2 is on, right? If D2 is on, because cathode is connected to negative voltage, so this time D1 is off, but D2 is on. Once it is on, the voltages will change. Your V01 is still 10 volts, and your V02 is 0 volts because it is connected to ground. And the potential difference is dropped here. The 10 volts is dropped across the resistor here, 1K, right? 2K. And let me check D1 again. Let me check D1. So this is D1 now, once again. Because the voltage has changed, so this is 10 volts. This is going to be 0 volts. So this diode is still off. It is still off, right? So your V01 is 10, your V02 is going to be 0. See here, we want to do by method 2, right? Second method. I mean, you can have whatever method you want. So I've given 10 volt here, minus 10, right? 5K, 10K. So first, I told you to check D1. When you check D1, you'll get some node. If this voltage, if this node or this node here is positive, then D2 is reverse. If this node is negative, then D2 is forward, right? So second method, what you can do is, you can test one diode at a time, but who is an element of doubt here? Anode is at 10, cathode is at minus 10. So D1 is, however, forward, right? But anode is at ground and cathode is at minus 10 for D2. For D2, anode is connected to ground and cathode is connected to minus 10, right? So D2 is maybe is an element of doubt, because some students are asking in the comment section why you're going for D1 only, right? So nothing, there's no rule like that. I can go for D2 also. So if I go for D2, then I'll replace diode by short circuit D1 and D2. And this is the direction of current. I, this ground, minus 10, 10. Right? Now, when is D2 forward? I'm testing D2. Please test D2. I'm testing D2, right? So if this current happens to be positive, then the diode is forward. Once it is not forward, I can say that I can have to test only D1. So D1 is however forward by seeing, right? Okay. So let's see what is I. If this is ground, then this voltage is 0. This node is already at 0. You can take some current Ix here and this as I1. So every branch you can take a current. Now the currents that are entering the node is equal to the current leaving, KCL. I plus Ix is equal to I1. Or I is Iy minus Ix. Iy minus Ix, right? Now what is Iy? Iy is going to be 0 minus of minus 10 by 10K. It's 1 milli. And what is Ix? It is 10 minus 0 by 5K, 2 milli. 1 minus 2 is minus 1 milliampere. Minus 1 milli. Can a current be negative? No. So diode D2 is reverse bias. If D2 is reverse bias, I will replace D2 with what switch? Open switch. Now I have only D1. I have only D1. This is 10 volts. This is minus 10, D1. Here we have 5K and 10K. We have 5K and 10K. And what is this voltage V0? So you can take a current here. This current I happens to be positive, right? What is I? We have already seen this. We already got the current 10 minus of minus 10 by 5K plus 10K. It is 20 by 15. 20 by 15K. Previously it was 3K, no? Oh, previously I took 2K and 1K. Okay, doesn't matter. The ratio is same, 5K and 10K, so 20 by 15K. So what is V0? V0 is going to be 10 minus drop. It is 10 minus 20 by 15K into 5K. 5 3s are 15. It's going to be 5 3s are 15, 20 by 3, 6. So it's minus 3.33. Now this is exactly what we got in the previous case. I told you when I have a diode like this, and my voltage here is minus 3.33. Do you think a diode here, was a diode here, minus 3.3? Is it minus 5 threes are 36 plus 3.33? This plus 3.33, and here I have a diode like this. This diode is naturally off. When the diode is off, your V0 is still how much? Plus 3.3. So this is exactly what we got in the previous. In the previous case, you can just check the circuit. Oh my God. Why all this is coming? You can check the circuit in the previous case. So you do this problem as a homework, you do this problem in the normal procedure. So now previously I did D1 test. So D1 you take alone, you get here plus 3.33. So when this node becomes plus 3.33 here, then naturally D2 is going to get what? Off. Are you getting? Right? So the upper resistor is smaller one and the lower resistor is larger. Tell me in which problem we have upper resistor smaller and the lower one larger here. Upper resistor smaller and the lower one larger. Upper resistors. Where is this? Yeah, this one. The upper resistor smaller and the lower one larger. Yeah, this is figure 3. All of you. So you can make a note. This is figure 3. So let's see what happened in figure 3 here. Figure 3, your V0 is figure 3. Figure 3. Your V0 is 3.33. The diode is off. So this problem, the figure 3 of the first problem, I have repeated it with the second with the second method. Right. This is. So method 2. So just for your reference, I'm writing this was figure 3 of the first problem, right? This was figure 3 of the first problem. I'm doing it by the second method. So finally, if anode is more positive than cathode, the diode is forward, or if the current flowing through the diode is positive, then the diode sustains a positive current, right? So you can do, so you always try to make a plausible assumption, right? Some logic you can apply. It comes by practice. More problems you do, it's much better for you, right? Now this is a simple gate problem. The simple gate problem, the examiner is asking, find ID1. I mean, just by inspection you can do it. You don't have to solve, nothing is there. You just have to apply logic. This is a gate problem. This is a gate problem, right? Find ID1 and ID2. Now see here, what do you mean by a loop? A loop means you should start at one point. You should start at one point and then you have to come back to the same point, right? So the current I start and then come back to the same point. That's a loop, right? So how do you travel? So when you are in a loop, you should not get stuck somewhere else, right? So loop means what? The starting point and the ending point should be same. So sometimes what students do, they start at one point and they form a loop somewhere here. That is wrong, right? This is wrong. You should start at one point and you have to come back to the same point. It's not like you start from home and go to a mall and then visit the mall and then come home, right? You just not go to the start from home, go to the mall and keep roaming in the mall and form a loop somewhere there, right? So it's not like that. So when the current is flowing, it has to come back to the same point. Now you tell me, the current I is traveling like this, like this. It has two paths for it to flow. It has two paths for it to flow. And I told you, current will flow only from anode to cathode, not from cathode to anode, right? So if the current is traveling from here, I, will it choose D1 path or resistor path? Which one is a low resistance path? A reverse bias diode is low resistance or the resistor is low resistance? Which one is low resistance, right? Do you think current will flow from cathode to anode? No. So now the current has to travel through the resistor. It has to travel through the resistor, right? It has to travel through the resistor. Now, after it has traveled through the resistor here, again it has two paths for it to flow. Again, it has two paths for it to flow. Which one is the shortest path? The short-circuited diode current flowing from anode to cathode or the resistor? Which one is the shortest path? The shortest path happens to be the diode, because the diode, once it is on, it's ideal, it can be replaced by short circuit. So the D1 current is going to flow like this. So let me repeat. This current has two paths for it to flow. It cannot flow through D1, it has to flow through R. But now it has a node here. It can go through R or it can go through a short-circuited diode. Which one is the shortest path? The diode, right? But some students, what they do is they just come here and they get stuck in D1 loop and then they keep roaming around like this. So that's wrong, right? When you start from home, right? So you go to the market and don't stay in the market. You have to come back home. So the best way to come back home is to choose what R. When D1 is bypassed, you have to go to R and then D2 and then come back, right? So now you tell me, what is ID1? ID1 is same as I, but what is ID2? ID2, no current will flow, it is 0, right? So this is a gate problem for 2 marks. The simple problem, right? So you have to just move around, you have to move the pen, right? Like the Pac-Man, you just keep moving the pen like this and see if there are two paths, which one to move. So how is it moving? It goes like this and then comes back like this, right? Are you getting? So ID1 is I and ID2 is 0. Oh, I think the time is up. So, yeah. Fine. We shall continue more of such simple problems, because in GATE exam, you'll find such simple problems. So you will see, right? So you can have some question answer session now. Yeah, Venkat, please unmute the students. I want to talk to them.
Hello.
Okay. Yes.
Good evening, sir.
Good evening.
Sir, actually, I have 2 doubts in yesterday's class. Can you please open that tab?
Okay. What is the doubt?
Sir, it's related to questions, not concept based.
Okay. Yeah. Which question is that?
Sir, in page number 7F, yesterday's class.
Yeah.
Yes, sir. In here, you considered the impedance, equivalent of impedance just as 1 by SC. Why didn't you consider resistors as well?
There is a resistor. The current is flowing, IT is flowing
Hello,
only
sir.
through Z, no? IT is VT minus V0 by Z. Where is the
Okay.
resistor here?
I thought we are taking equivalence, so we have to consider the whole circuit.
No. You see the current simple Ohm's law. I have an impedance Z. I can write here. There is VT here, there is V0 here, there is Z here, and the whole current IT travels here. So by Ohm's law, what is IT? IT is V1 minus V2 by R. Am I right?
Yeah. Yes, sir.
VT minus V0 by Z. Yeah. Second
Okay,
question.
fine. And 10F.
This
Yes, sir.
one?
In this one, why can't we solve it like taking the equivalent of resistors that are entering and then solving it?
Where you want to take the equivalent of resistance? Here
So,
at this point, at this 10K you want to take?
no, sir. Like we do in finding the equivalent resistor, na?
Yeah. At what node you want to find? You
So
want to find
entering from 10K and then taking that parallel 10K and then it becomes a series and then 5K.
Yeah, I mean, these two are in parallel. The combination is, that means you're looking through this arrow,
Yes, sir.
which I've drawn here.
No,
This
no,
one.
no. From the input side.
From the input side, then see, simple. When you're taking
Mhm.
equivalent, if I
Yes,
put
sir.
an arrow this side, right side, then you have to reduce from left side. If I put an arrow left side, you have to reduce from right side. Because you said 10K parallel 10K, that is when I have written, see here. Are you getting what I'm saying? Yeah, see here. Suppose I have a network like this.
Yes, sir.
And here there's a voltage source. Now you short it. You're saying this is 10K, right? This 10K. 10K parallel 10K is 5. 5 plus 5 is 10. And then this is parallel with 10. So you're seeing through this one now. So all this you're reducing. First you put this 10K in parallel. And then you combine them. So when you're combining them, when you see from the right side, you have to reduce through the left side. So yes, you can do it, provided, yeah, what is the number you said?
10F.
Yeah, you can do, but the problem is you will have an equivalent resistance from here, but you should have an equivalent voltage at 10K. The equivalent voltage at 10K, again, you have to take a node and solve. That's a headache.
Okay, so we cannot do it
But in
directly.
fact,
That's
what I
what
have done is also the same thing.
Yeah, that's what I'm confused. That when we
No.
take resist.
See, the point is, I'm cutting each 2 resistor with a voltage source, and then I'm drawing an equivalent for it, right? This is called the Thevenin equivalent. What is the Thevenin equivalent here? You just cut it till here, and then you get 4 here in series with 5. Then the 5 and 5 becomes 10.
So why aren't we able to do it directly? That's what.
So how you're going to do directly? Because you will get voltage, but you will not get resistance. How you're going to get voltage, tell me? If you say that if this is 8, this is 4, you're wrong. Some students say, see, you might get an answer, but that is wrong, no? Because you cannot apply voltage division when the current divides. The current through 10K and this 10K should be same. Then only you can apply voltage division.
Okay.
You cannot apply voltage division half. You cannot say this is half 4. No, it was half after cutting it. And there is a loading effect. There is an extra 5K in series. So the equivalent of this 8, 10K, 10K is not just 4. It is 4 in series with 5K, which you see here. Can you see here?
Yes, yes.
At this point.
Okay, I got
You
it.
getting? So that extra 5K should come into picture. That is why you have to cut it and do it.
Okay. Thank you so much, sir. That's it.
Hello? Hello?
Yes.
Sir, in page number 53F, sir.
Yesterday or today?
Today's class, sir.
Okay. Tell me.
53F, sir.
No, I'm not a
53.
Yes, sir.
So many pages I've written today. Oh, 53F. Yeah.
Yes, sir. In method 2, you have said that D1 is forward bias, no, sir.
No. This is a current test I'm doing. I'm allowing currents to flow. If the current happens to be positive through I, then the diode is forward. The previous case, I was doing an open circuited test. We just open circuit and then calculate. Now they're saying that why can't you test D1, D2? So I've applied a short circuited test. This is a short circuit. What do you mean by short circuited test? Replace all diodes by what circuit? Short, and calculate the current. If the current is positive, then the diode is forward. Are you getting?
Okay, sir. Then, if in the D2,
Yeah.
since it flows from negative to, cathode to anode, you have considered it as a reverse bias, sir?
No.
Indeed.
I have considered it reverse bias because my answer is negative. Yeah. It is showing that as if the current is flowing from cathode to anode. You are right.
Then we
But
can take
current
it
cannot
as
flow in the reverse direction.
okay.
Let me
From
show you.
this-
Yeah, let me show you like this. The same circuit, you can draw it like this. See, I have drawn like this, right?
Yes, sir.
Suppose if the nodes are really creating a problem for you, you can do one thing. After going home, this is D1, D2. This was 5K, 10K, am I right?
Yes, sir.
Yeah. Some problem I've given. Don't worry about the numbers. Now, if you want to know how currents are flowing, then you take first ground like this. Are you getting?
Okay.
Then from ground, it is connected to D2. D2 anode, it is given to
Minus
cathode
10.
is given to 10K. 10K other end is given to minus 10.
Yes, sir.
But the same D2 is given to D1 cathode, and the other end is given to 5K with 10. Here you are finding the output. The output is taken at anode. Here, this one. So I think this is, are you comfortable with this now?
Yes, sir.
Yeah. Now what you can do is, suppose you want to test D2, you take a current, right? Short this one and short this one, both. And if that current is positive in this circuit, naturally the diode, if the current flowing here is positive, if you place a diode, the diode will naturally be on, no?
Yes, sir.
Yes or no?
Yes,
So you
sir.
calculate the currents in this circuit, replace D2 with what circuit? Short. Take a current. If I is positive, then who is forward? D2 is forward. Are you getting? If D2 is forward, you replace him by short. You get, this is ground, so you get 0 here. And see if this guy is on. If that guy is also on, that is fine. Otherwise, if D2 is if the current is negative, if I is negative, like
Okay.
what we had, then D2 is off. Are you getting?
Yes, sir.
Yeah. Okay.
So we should take while calculating one at a time, sir.
Yeah, you
While
replace all
calculating
by
I-
short. But you see, when I'm calculating a current, how can I calculate both? My focus is at one point only, no?
So we
As
are
a human being, we will
calculating
always
current
alleviate the problem one by one. So we calculate one current. If that
in
is
D1.
positive, then we can go.
either in
Yes, sir?
D1 or in D2.
Yeah, D1 or D2. D2 you can take. D2
Okay,
you can take and calculate. That's what I'm saying, no? If once D2 is also on, you calculate D1 and see, your answer is not going to change. See, already we have followed one method.
Yes, sir.
That method is simple, no? First we took some diode, and after that we have just seen the polarities. Yes or no? You
Yes,
can
sir, that
confirm
is
with this
short
method also,
circuit.
I'm saying.
Okay.
Are you
This is
getting?
through current and that is through by seeing
Yes,
anode
that
and
is through
cathode.
potential difference. This is to current. Both are same only. Because in the comment section, I was told that, sir, why you always going from D1 to D2? Can you go from D2 to D1? Then I said, okay, let me go for the short circuited test.
Okay. Sir, in page number 30F, sir.
30,
F, 30F.
30F.
Yes, sir.
Okay, 30, right?
Yes, sir.
This one. Yeah.
So can you explain how how we got V naught equals to 2? For the
Yeah,
case
first I'm removing this section, the middle one. What is VOC? VOC is V in by 2. You don't have a problem?
No, sir. I
Yeah.
understand.
If VOC is V in by 2, if V in by 2 is greater than 2, the diode is on. Once the diode is on, what is the voltage between the 2 points? Between these 2 points? Can you see my pen here?
Yes, sir.
Yeah. Between the 2 points, what is the voltage here? 2.
2.
What is the voltage here? 2. What is the voltage here? 2. What is the voltage here? 2. What is the voltage here? 2. The voltage here is 2 only.
But won't
Same
there be
node, right?
any drop near resistor, sir?
Yeah. If this is 2, this is 2. And V in minus 2 will be dropped across resistor. V in minus 2. For example, if V in is 5, you'll have 3 volt across the series resistance.
No, sir.
If
In
V in
the
is
last
1000,
resistor.
suppose V in is 1000, 998 is dropped across this series resistance. But the parallel resistor will always have 2.
There will be a drop, no, sir, in the parallel resistor.
Yeah, that is 2 only. The current is nothing but 2 by R. The current is 2 by R because the voltage is 2. What is 2 by R into R is what? 2. See, in parallel, let me tell you something here. In parallel, here, the voltage is not going to change, right? So suppose I have 5 volt. What is the voltage here, you tell me? What is the voltage here? It is 5. If I put 1 kilo ohm, what is the voltage here? 5. If I put one more 1 kilo ohm, the voltage is 5. So this is exactly, you will see in your house, you have 230 volts and only one fan is on. It is 230. What if the other fan, tube light is on or AC is on? So in a parallel connection, the voltage will always remain same. Only the load current will, according to the load, if it is R1, 230 by R1. If it is R2, 230 by R2. So the current will change in parallel connection, but voltage will not change.
Okay. Sir,
Are
you
you getting-
said that, yes, sir.
Yeah.
You have told that we should, for checking, finding out the positive and negative terminal voltages, you said to go for VOC, open circuit test, no, sir?
Yes. You can go for an open circuited test.
So,
Calculate it, and after that, based on that, you can justify.
whether it is a forward bias or
Yes.
reverse bias.
See, it comes by practice. When you are doing by more than one method, new problems. Are you getting?
Yes, sir.
Yeah.
Okay. Thank you,
And
sir.
please do the same problems once again. Don't do anything new. Same problems you analyze each one. Are you getting?
Yes, sir.
Yeah.
Thank you.
Hello, sir.
Good evening,
Yes.
sir. Hi, Wes.
Sir, page number 55F, sir.
55.
Yes, sir. Sir, I
This one?
didn't understand like why we choose the path from R, like first one.
Why we didn't choose D1?
Not- Yeah, sir. Why didn't we choose D1? Why
No,
is
how
it
current can flow from cathode to anode? A diode current will flow only from anode to cathode. Cathode to anode, it will not flow.
Okay, sir.
Are you getting?
Yes, sir. Yes.
Yeah. Good.
Hello, sir.
Yes.
Sir, in the same
Sir, I
slide,
have a doubt.
In the
Sir,
same slide.
ID1 is 0 and ID2 is I, right, sir?
ID1 is 0 and ID2 is I. Yeah, you're right.
It's just a mistake.
Oh, I missed it here. Okay. I'm writing ID1. This one is D1, huh?
D2.
This,
D2.
I wrote ID1 as, acha, I'll do one thing. Yeah, I'll make this D1 and this as D2. Are you getting? Because
Yes,
I
sir.
marked here as D1. Are you getting?
Yes, sir.
Good catch. You're right.
Okay, sir. Thank you.
Yeah.
Sir, actually in 10F. Hello?
Yeah, tell me.
Sir, 13F, sir.
13F.
Starting one slide, sir. 13 or 14F something, maybe.
Yeah.
Sir, not this one, maybe second one.
This one?
No, sir, next one. Sorry, sir. Sir, this one. So actually, I just want to ask that can't we use voltage division here?
Yes, we can use,
Like at
but
one
the point is, this is a diode, not a buffer.
Yes,
If
sir.
you have a buffer at this point, can you see my pen here?
Yes, sir.
If I have a buffer with infinite input resistance, where no current will flow here, then you can use voltage division. Voltage division is used only when same current flows through both the resistors. See here, what is voltage division? This is V, this is R1, this is R2. Are you getting?
Yes, sir, I get the concept, but I
Now,
have
if
a
you
doubt.
have R3, can you apply? You cannot apply.
No, sir.
Yeah.
But sir, I have a doubt that how can we get the same answer as the normal method when we use voltage voltage division?
In
Like in
voltage
the-
division, you cannot get the answer. Tell me, what is your answer? Here you will have 6 volts by
Same.
voltage division.
Yes, sir.
Here
in
you will
this,
have 3 volts. Where are the resistors?
I get 3 in parallel with 6 as 2K and
No,
10
no,
to
no, no, no. How did you get that? You see, there is 6, there is 3. Now what are you going to do there? But the resistors, how you are going to get? But if you say I have 2K, then you have followed this procedure, not voltage division. This is the
Okay.
procedure where you remove the resistance, because if you do voltage division, you are calculating the voltage at that point. See here, remember, let me tell you, the voltage, what is the voltage at this point? You tell me.
So, 6 volts.
No, it is 6 minus ID into 2K. Suppose this is A, this is B. Who is A, you tell me? Is it anode or cathode? A.
So anode.
Anode, this is A.
Yes, sir.
Cathode is B. What is A? It is 6 minus ID into 2K.
Yes, sir. Yes, sir.
Are you getting?
Yes, sir.
Yeah, it is not 6. If it is 6, your voltage division is correct. It's not 6, it is 6 minus ID into 2K. Now, let me put your own, the same idea in future. See here, suppose I am having a BJT here, like this. And here you have R1 and R2, and this is VCC. Tell me what is the voltage at this point here? If you say VCC R2 by R1 plus R2, you're wrong. It is VCC R2 by R1 plus R2 minus IB into R1 parallel R2.
Okay,
So
sir.
are you getting? By looking at this, we can jump to VCC R2 by R1 plus, but that's wrong. You have to cut that and you have to draw an equivalent like this, and then you will know it. So this is something which I will teach you there. Are you getting?
Okay,
Then
sir.
you have a resistor here, and then you have a base current IB flowing. So if you say what is the voltage here, it's not VCC R2 by R1 plus R2. It's VCC R2 by R1 plus R2 minus IB into R1 parallel R2. Are you getting?
Yes, sir. Yes, sir. Okay, sir. Thank
Good.
you, sir.
Yeah.
Hello,
Yeah.
sir.
Yeah. Tell me.
Hello. Sir, I just wanted to ask, in the past 1 hour, whatever problems we did, why have we considered the ideal diode case? Like, why have we taken a short circuit for forward bias case and not 0.7 as the voltage?
No. For every problem, I have some problems I've given 0.7. See here, this is the problem we have done. What did I took here? VD equal to how many volts?
0.7.
0.7. So I took 0.7. And then I came for other problems. I said diode is ideal. So I took short circuit. And then for the second problem, I took VD equal to 0.7.
Okay.
VD 0.7. So there are some problems where I took ideal. There are mostly I've done ideal because gate problems are filled with ideal diodes.
Oh, so we normally solve it using ideal diode.
No. Examiner will give. We cannot solve. The examiner said, consider the diode ideal and what is the voltage at this point. If VD on equal to 0.7, what is the voltage? If the examiner gives VD on 0.7, take it like a practical diode 0.7. If the examiner, the examiner has to mention, no?
Okay, and what if he doesn't mention, sir? We just take it as practical?
No. If he doesn't mention, then ID equal to IS into e power VD by VT.
Oh, okay.
Non-linear.
Okay, sir.
Are you getting?
Yes, sir.
Yeah, because that is a natural form. The hardcore diode is having that sort of a characteristic. ID equal to A e power BVD.
Okay.
This is
Okay.
all these problems we are doing by assuming them as what linear? Piecewise linear, neglecting that small microampere region.
Okay.
Are you getting?
Yes, sir. Thank
Yeah.
you, sir.
Yeah.
Good evening, sir.
Good evening.
Sir, I want to know a small concept. When you were discussing regarding the inverters connected in parallel,
Yeah.
so both of them should be at the same voltage level and charged using a balanced charger, no, sir?
Yeah. Mostly, see, every battery has got some internal resistance, right?
Yes, sir.
So that will come in series. It can sustain. So these two batteries are connected in parallel.
Okay.
And when they are charging, then the automatically the current has to get divided because those batteries are chargeable batteries. Yeah, you are right.
Yes, sir. Why I got the doubt is when we are charging lithium-ion batteries, we should use a balanced charger. Else, one battery will try to charge the other, and
and once that happens, it just blows. You're right.
Yeah, sir. That was
because there's an imbalance.
Okay, sir. Thank
Very
you,
good.
sir.
Very good.
Sir, yesterday's lecture, page
Ah.
3F. Yesterday's lecture, page 3F.
Yesterday's lecture, page. Yesterday's lecture, page.
3F.
Yeah.
Sir, the voltage at non-inverting terminal is -3 volts. So
Yeah.
there will be a current flowing from the ground to the from left to right through that 5 kilo ohm resistor. So
Okay.
if that current needs to enter the 3 volt voltage source, that 3
Yes.
volt battery. But why,
Okay.
sir, a current will be flowing into the battery if there is only 3 volt across the battery? That is like putting 2 3 volt batteries in parallel, and one battery starts charging the other. The current should not enter the 3 volt battery,
The current should not enter the 3 volt battery.
because there is only 3 volt across the voltage source only.
Okay.
So
No,
if
you are
there is
saying
only-
that this Vn has to be Vp, which is how much? -3, right? This is -3.
this is -3, and Vout
Yeah, you
is
are saying that
-6,
this ground is at higher potential.
and there will be a current from left
A
to
current
right.
flow in this direction. Are you right?
Yes, sir. Now
Very
that
good.
current will enter the 3 volt
Positive
voltage source.
terminal. Yes. See, remember, 3 volt is not strong here. Op amp is strong. There is a much larger power supply, no? All these currents are flowing not because of the 3.
No, sir, there is only 3 volt voltage difference across the voltage source. The Vn is at -3, Vout is at -6.
Yes,
so-
this is, yeah, this one is -3, no?
Yes,
And
sir,
this is
and
-6. What is -3 minus of -6 is 3.
Yes, sir, we are putting 3 volt across a 3 volt battery. So why a current will be flowing into that battery?
We are putting a 3 volt. See, if the
3 volt
current does not
potential
flow through the
difference.
battery, how you can set up virtual ground? How you can do that error correction when there is no feedback?
Yes, sir, I understand. I was just thinking that.
See, suppose there is a 3 volt source and no current is flowing through the source. How can the 5K have a drop of -3 then? For 5K to have a drop of -3, there should be some current flow in the loop. Batteries will have currents, right? What's your doubt?
Sir, my doubt is, if I take a 3 volt battery and puts an external potential difference of 3 volt in the same polarity, positive with positive, negative with negative, no current should enter the battery. So why
No.
there is a-
You see, the battery negative terminal is at -6, my dear. Positive terminal is at -3.
Yes, sir.
Negative terminal is at -6. Positive terminal is at -3. So what is the difference from positive to negative? -3 minus of -6 is 3 only. It is satisfied, no?
Okay, sir.
Are you getting?
Okay, sir.
What is your doubt? You are thinking only about that -3, no? What about V0?
Okay.
V0 is at -6. The difference -3 minus of -6 is 3. Satisfied. Kirchhoff's law, we have not violated anything.
Okay, sir. Okay.
Yeah.
Sir, in same 7F.
NF?
7F.
Yeah.
Yeah, sir, in this, in V0, why didn't we consider this line having C capacitance? The
A
first
line
equation. In the first equation, V0 equal to -R2 by R1 VT. Why didn't we consider this line having capacitance C?
No, VT is this value, right? Can you see
Yes,
my
sir.
pen?
Yes, yes.
Yeah, this is virtual ground 0. This is an inverting amplifier. So let us apply KCL now. That is why we call the output as voltage source. A source. So what is the current here? Let me write VT minus 0 by R1 equal to 0 minus V0 by R2. That's it. From here, V0 is minus R2 by R1 VT. Is it okay?
Yes, sir. I got this thing, but there is a connection from C also, right? Through C capacitance.
Yes, my dear. Whether there is C or L or Z or R, this V0 is V0 only.
Okay.
V0 is the potential, no?
Okay.
Current is this voltage minus V naught by R2. But if that has connection, who cares, sir? Yeah, I've understood your doubt. What you're trying to say is, see here, let me push this fellow. Yeah. Now, let me give you an example. See here, suppose I have here 5 volt. I have here 3 volt. And there is R. What is the current I? 5 minus 3 by R. What if I put a capacitor here, an inductor here, a resistor here? But this is 3. So the current will still remain same, no? Are you
Yes,
getting?
sir. Yes, sir.
Yeah. Because that's what a source means. Tell
Okay,
me.
sir. Got it.
Yeah.
Hello, sir. Hello.
Good evening, sir.
Good evening.
Today's slide, last page, last question.
Last page.
Today's slide.
Okay.
Oh, sorry, this is yesterday's lecture, sir.
This one? This is yesterday's, huh?
Oh, yeah, it is today's.
This is all yesterday's, okay. You want today's. Oh. Yeah, tell me. Hello.
Yes, sir. Last.
This one?
Yes, sir.
Yeah.
Sir, so current is flowing from down to up, right?
Yeah, current is flowing. If I start from A,
Yes.
this
A to-
A, B, I should start at A and come back to A. Can you suggest me?
No. So my doubt is voltage at A should be higher than voltage at B, right?
Voltage at
A.
A
should
is
be-
higher than voltage at B.
Yes.
Yeah, it's okay. This is a current source, no? Current will travel. Don't
Yes.
worry about voltage.
Yes, sir. And is short, right? So across B1, we will get A voltage and B voltage, right?
Across
B1.
D1.
Yes.
Across D1, you have B as well as
A.
Yeah, this is B, and you're having A here. Okay. But this
Yes.
B minus drop, IR drop will be there. Yeah.
Okay. So then I'm not getting actually because D2 is shorted, right?
D2 is on. Yeah.
Yeah. So at the positive at cathode also of D1 we have A voltage.
This one is, yeah, we made this as what?
Fault.
This we made at D1 and this as D2, no? Yeah. This is D1. Yeah. Tell me.
No. What I'm saying is that D1 will be closed circuit, right?
No,
D1.
upper diode or lower diode, you tell me like that. Upper
Low-
one or lower one?
Lower one.
Lower one is on. Yes.
On, right? So please draw the line there. Make it short.
Yeah, we have made it short. Yes.
Okay. So at the cathode of D2, we have the voltage A.
Okay. Acha, you are saying both are at same potential.
No, across D2, we have A and A voltage.
Okay, if this is A, this is also A, you mean?
Yes.
Okay, so
Now D2 will be forward bias because A is greater than B.
A is greater than B.
Yes.
How come A is greater than B?
because from the outer loop, current is flowing from A to B. So,
See, there is an IR drop here. First of all, see, you're messing things up after getting shot. I'll tell you something.
okay, sir.
This is 5K, this is 5 volt. Are you getting? Now, if you say that this is ground and how this is ground, how current will flow. See, after shot, naturally there will be a loop, no, forming.
Yes.
Why are you worried about a short? I'm saying this is short because previously there was a higher potential and lower potential. That is when the short has come. Now you are trying to backtrack your idea. You're saying that it is on. Now, if it is on, then this is short. How there is a potential difference? There is no potential difference. How current will flow? Are you getting?
Yes, sir. Yes, sir. Got it.
You're backtracking the idea.
Backtracking. Yeah. Okay. Okay. Thank you, sir.
Okay.
Sir?
Yes,
sir. Sir, yesterday's Miller integration problem, we have connected DC voltage, sir, with 1 volt.
Yes.
Where the capacitor is getting charged with VC is equals to V by RC into T.
Yes, yes.
Sir, here we are connecting the DC voltage, no, sir, but the capacitor should be the open circuit as we are connecting the DC voltage.
Yes, yes, you are right. Open circuit means it is fully charging. Don't say open means it is open. When you open, whole charge, see, it is like capacitor is like eating food. When you will say that, when I will say that I don't want food, after I have eaten full. Are you getting? So similarly, capacitor is getting open means where is that charge? The full charge is in capacitor only. Because in an open circuit, full voltage will be there. So capacitor is charging from T equal to 0 to a final value where it is fully charged. And after that, there is no current. That means it is an open circuit. It's like your battery. Once your battery is fully charged, what you'll do? You'll open it from the socket. The whole charge is there in the battery. Now you can use it for speaking.
Yes, sir.
Are you getting?
Yes, sir.
Yeah.
Good evening, sir.
Yes.
So in some cases when there are many diodes and sometimes when can we say which one will switch first, which one will short first?
See, that is what we don't see. We have to make a plausible assumption, an intelligent guess. If in the first case problems, what we have done is we know one is 10 and the other one is minus 10. We have got sure D1 is on. We went and checked for D2. If you have an element of doubt, then you can always follow second method, replace all diodes with short. And you can take one at a time.
Okay, but can we say when we open all of them and if the potential
See, the point is, a load is always current driven. Because if you open all of them, no current will flow. No? Then how will you calculate the IR drop?
Yeah, but
open circuiting for single diode is okay. Because there is no other switch. If there are 2 or more switches, then open circuiting you have to cleverly do.
Okay, like some problems are like I had seen in open circuit, they have made all diodes open and whichever is having higher potential, they are switching that one on first.
After that, once they get on, after that the voltages will change, you know.
Yeah.
When it changes, you have to cross check. Don't come to a conclusion. Because see, when circuit changes, now you are saying one is on. When you say one is on, you are closing it. Current will flow. When current flows, there will be IR drops.
Yes.
When there are IR drops, again you have to recheck. If you directly conclude, you have to recheck whether your assumption is true or something else has been done. Okay.
Yeah. Thank you, sir.
Yeah.
Hello,
Good
sir.
evening.
Hello.
Good evening, sir.
Yeah. Good evening.
Sir, please open that 3 diodes problem, sir.
Which problem?
Last set of 3 diodes.
This one?
Yes, sir. Yes, sir.
Yeah.
Here, assume that first figure A is not there, sir.
First?
Figure A is not there.
Yes, figure A is not there.
Sir. D1, we decided D1 is on. We don't know about D1 now.
Yeah. See, that is what I'm saying. Without figure A, I have already done a problem where I short circuited both the diodes, no?
Sir, okay, sir. Please, I have a doubt.
You take a current and check.
Sir, you decide if you have only figure B, sir.
Okay.
You directly said that D1 is on. Sir, my doubt is,
see, a diode is on only when the current flowing through the diode is positive. Even if you check after that, you have to calculate current, I'm saying.
yes, sir, that method too is clear, sir. But this for saying D1 is on, should we open circuit D2?
That is what, see, D1 anode is at 10, the cathode is at minus 10, no?
Cathode
it is experiencing larger potential difference naturally than D2.
Yes, sir.
So because D2 one end is at ground, here D1 one end is at 10, and they have a common node in the middle here. Can you see a common node?
Yes, sir. Yes.
Yeah, so naturally D1 is experiencing more. So you can make a plausible assumption. Let me check D1 first and then go for D2 to see, otherwise I'll tell you, when two switches are there, you are having 4 combinations, no?
Yes, sir.
0, 0, 0, 1, 1, 0. 4 times who will do? At least 4 times, you don't have to do 3 times. Can we make it to 2? That is the idea. Can we reduce it to 2 combinations? First check one, the other one. Are you getting? But
Yes,
what
sir.
you are saying is also correct. Suppose we made a wrong guess, then we have to go for the 3rd time and recheck.
Okay, okay, sir.
Yes or no?
Yes, sir.
Instead, short both the diodes, take a current and do. That is also okay. Please, for 2 diode problems, you practice. When you are practicing, you will get an idea. Are you getting?
Sir, I'm not very sure, sir. If I get a doubt, I will again come to you, sir.
Yes, 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 yes. No, but what you have said is absolutely right. How will you make, if D1 circuit is not there, the D2, the second figure is given, how will you start the analysis? You can start the analysis by looking at the diode, one end is shorted, the other end experiences different potentials.
Yes, sir. Yes,
Right?
Yes, sir. Right.
Yeah, so D1 is experiencing more, so I went for D1. Fine. Anybody else?
The page number 16F.
16F. Yeah.
Sir, not this one. I guess the previous page.
Okay.
So the initial questions we told. Page number 13 or 14F maybe.
Page number
13 or
14F. This one?
14F. No,
This
sir.
one?
No.
This one?
Yeah, this one. So for these type of questions, can I conclude that if the word ideal diode is mentioned, then we always have to directly, blindly, we have to short circuit the diode
Yeah.
and
You're
then
right.
proceed.
We have to short circuit the diode, and the short circuit is valid only after you calculate the current and you find that the current is positive.
Okay, and no case for open circuit if the diode is ideal.
Yeah, if the current is negative, then you have
Yeah,
to say that the diode is what you call reverse bias. So you have to open circuit and check. Simple. The same problem, if I interchange the diode, then what will be your answer? The same problem, if I reverse the diode, naturally the current will be negative, no?
Yeah.
If the current is negative, then the diode is replaced by what switch? Open switch. So this will be the diode. Here you are having 6 volts. Here you are having 3 volts, open circuit. So now the current is negative, there is no flow of current. So here you are having 3 volts. This is a diode. So now you tell me what is the voltage VD? This is 3, this is 6. 3 minus 6 minus 3 volt will be there. So VD is negative. That means the diode is what bias? Reverse bias.
Reverse bias. And sir, yes sir. And sir, for transfer, for the questions in which we have to find the transfer characteristics,
Yeah.
sir, there we have to check for open circuit and short circuit for both, right? Even if
You
the
just
diode is
calculate.
ideal, then too.
See, all the transfer characteristic I made simple by calculating only 2 voltages. One is the anode voltage, the other one is what voltage? Cathode. Anode greater than cathode, diode is forward bias. Cathode greater than anode, diode is reverse bias. See, this single diode problems, they are much simpler because you don't have to even calculate current. You have to just calculate anode voltage, cathode voltage, and you can finish it.
Answer page number 47F.
Yeah.
So can you explain the figure 2B part?
Yeah, figure 1, we have got how much voltage? Minus 3.33 here. Can you see my pen?
Yes, sir.
So negative is at anode, ground, the cathode is at ground. What is anode minus cathode voltage? Anode is negative, cathode is at higher potential now. Minus 3.33 minus 0 is negative, minus 3.33 volt across it. Diode is naturally off, no?
Yes, sir.
Yeah.
Okay, sir.
Suppose instead of minus 3.33, if it is plus 3.33, anode is positive, naturally the diode is on.
On.
Yeah.
Anode voltage will be greater.
Yeah, anode is greater.
Okay, sir. Thank you.
Yeah.
Hello, sir.
Yes.
Sir, you told about load sharing concept there. You said that if two voltages are connected in parallel, if they have different value, then KVL is violated.
Yeah.
If they have same value, then it is allowed. So, can we apply Kirchhoff's law there, sir? I tried, but I'm not getting.
Yeah, we can apply.
Can you please show?
Don't apply superposition theorem.
Yes, sir. Yes, sir. That was the point where
Don't
I got
apply
stuck.
superposition because
Yes,
in
sir.
superposition there is a rule. The rule says that if you have two voltages of same value, you have to treat it as one first.
Okay.
And you have to take one and solve the problem. After finishing the problem, the current that is given, you have to divide it into two sources.
Okay. If
Okay.
Sir,
So
you can-
because you want
yes, sir.
you want me to apply KVL, I can apply KVL only like this. This one.
Yes.
This one for calculating I1. This one for calculating I2.
Okay.
Are you getting?
Yes, sir.
Yeah.
Okay. Thank you. Thank you very much.
Yes.
Hello, sir.
Yes.
Sir, that tree diagram first problem, sir.
Which diagram?
Sir, tree diagram problem. No, first one we did know that.
Today's first
For-
diagram.
No, sir, 45 F something. That tree diagram problem. No. V out finding
40.
5 F, sir. That somewhere like that.
This one.
Sir, tree diagram problem, sir. Yes. Sir, in that second and third figure is confusing me, this, sir.
This one.
Sir. Yes, sir. 1K up and 2K down. That. In that, no, sir. Next page, I think. Sir, three diagrams together we told, no, sir. Then finding V out. Then in second
This one?
and third. Yes, sir. In that second and third figure is confusing me, sir.
Confusing in the sense, see, only this node we have to calculate, no? V0 and this both are same when the diode is on. Can you see my pen?
Yes, sir.
This is also V0 only, no? If the diode is
sir.
on.
In that, no problem, sir. The next two figures, sir.
Yeah. See, once the second one, that's what I'm saying. Once you get the value, here, yeah, I'm putting two diodes here, like this. Now, if this value is positive, then the diode is what bias? Forward. If this value is negative, then the diode is reverse bias. If this value is negative, then the diode is forward. If this value is positive, then the diode is reverse. Can you see?
Yes, sir.
Now you got it?
Sir, but in second figure, the D2 is actually off, no, sir.
No. Have you understood
Yes,
these
sir.
two?
Yes, sir. This I understood, sir.
The same thing we applied there, no? Check. Are you getting?
Yes, sir. This no problem, sir. But still, in that figures, what I have done, there is.
Which problem?
Yes, sir. Next page, something I think.
Now I got it. In that problem, in this problem, this diode was off. But here we had negative voltage, no? and there's a diode here. So this was on. Is that what you mean?
Yeah, sir, that I can understand.
Because the cathode is connected to -10, no?
Sir, -10 on.
This cathode is connected to -10, anode is at 0. So you have to do the subtraction. 0 minus of -10 is +10 volt.
Okay, okay.
That is why this is on. Very good. Is this your doubt?
Sir, I think what I have drawn something, there is mistake. Then I'll recheck your slides, sir. Then.
Yeah, you verify and get back. Okay?
Okay, sir. Then
Right.
35F, sir.
Huh?
35F, sir.
Yeah.
Sir, in that first greater than 0.7 volt, can you please explain that portion once more?
See, for a diode to be on, the potential difference across it should be greater than 0.7. So what is the potential difference for a diode? Anode is at VOC, cathode is at ground. VOC minus 0 is VOC. So the diode has VOC across it. If VOC is greater than 0.7, then only the diode is on. But what is VOC by voltage division? It is V in R2 by R1 plus R2. Or you can do one thing. The same problem, we can draw it like this. We can draw it like this. This is V in. Here you have R1. Here you have what? R2. Am I right?
Yes, sir.
And then there's a diode. So you can do one thing. This you can, by source transformation, this voltage is going to be V in R2 by R1 plus R2 in series with R1 parallel R2. And now you have a diode. This is simple, no?
Yes, sir. This is
Now, this diode, open circuited voltage, if you open circuit and see, this node is going to be V in R2 by R1 plus R2. When this voltage is greater than how many volts?
0.7.
0.7, the diode will be on. Once the diode is on, the output is 0.7.
Yes.
But if the diode is off, diode on, V0 is 0.7. Diode off, V0 is going to be V in R2 by R1 plus R2. Are you getting?
Yes, sir. No worries.
Yeah.
Thank you, sir.
Okay.
Hello, sir.
Yes.
Today, class 13.
Today?
Third
13th
problem.
page, huh?
Third problems.
Third problem. Do you know the page number? This one? The second?
No, sir.
This one is third. No?
No, class starting. After this. After this, sir.
This one?
Yes, sir.
Tell me what is your
After
doubt?
reverse bias.
Once the
After
diode is reverse bias,
bias.
how did you find the voltage across diode? Is that your doubt?
Yes, sir.
Okay. This one. So once the diode is off,
Yes, sir.
same 8 milliampere is flowing in this direction, no?
Yes, sir.
So what is the drop across 1K? It is 8 milli into 1K is 8 volt.
8
You have
milli
5
volt.
volt supply, there is 8 volt drop. This voltage is -3, no?
Yes, sir.
Yeah, 5 minus 8. Or you can apply KVL. KVL says -5 plus 8 milli into 1K plus VD equal to 0. So your VD is going to be -3. Is it okay?
Okay, sir.
Yeah. Next, what is your doubt here? Now just tell me, what is the voltage across the current source? As a homework, what is the voltage across current source? 8 milli flows in 2K. 8 twos are 16, no?
16.
Then this -3 plus 16 will be the voltage across 8 milli. Such
Okay.
that the algebraic sum of voltage in a loop is 0. Are you getting?
Yes, sir.
Yeah.
Sir, again, 7th problem.
Page number?
Page number no.
This one? This one?
No, sir.
This one?
Previous.
What is there in that diagram?
Diode reference voltage 2 volts.
2 volt. This one?
Parallel with V in, sir.
This one?
Yes, sir.
This one?
Previous. Yes, sir. Previous one, sir. V in equal to V in by 2. BOC equal to V in by 2.
That's what I showed you. This one?
Yes, sir.
Yeah.
VOC equal to V in by 2.
If you remove the diode and 2 volts, you can apply voltage division, no? Okay, I'll do one thing. I'll draw the same circuit like this for you. The same circuit. See, V in. This is R, no? Instead of drawing R here, parallel, can I draw R here?
Yes, sir.
Can I draw? See, instead of here, I'm drawing here. The same node, no? The same node. Now I'll cut this. What is the voltage here by source transformation? V in by 2 in series with R. R parallel R by 2. Here we have a diode and 2 volts. No? Can you see?
Okay.
Yeah. Tell me, anybody, can we stop for today? 10. I have given you WhatsApp number, no? If you have any doubts, you can send me also. Is there anybody? Last question. We'll stop for today then.
Hello, sir.
Yeah.
Today's last second method, one second.
Second method.
Yes.
Tell me.
How the diodes will short circuit?
We don't know. We will replace them by short. If the current is positive, then our assumption is correct. So, see here, test D2, find I. Find I. If I is positive, then D2 is forward bias. Are you getting? Find I. If I is positive, then only D2 is forward. So we are just checking. But what did we get here? D2 is forward or reverse? Reverse, because the current is negative.
Okay.
Are you
The
getting?
previous question not okay.
Previous question we have
Previous
done
question.
with open circuited test. Here we have done with
Open circuit.
short.
In all previous questions, you taken short circuit, no, sir. In previous question, why you said open?
Yeah, see, this is another method here, that's all.
Okay. In the
Another
total
one
question,
more
open
method.
circuit you taken.
What?
Okay.
Yeah. Anybody else? Shall we stop for today? My daughter is calling. Anybody, if I've not attended to you, you can just post me. You have my WhatsApp number, right? Okay, thank you. Yeah, there is one more who's raising hand here. What happened? Voice is cut?
Sir,
Okay, then we'll stop. You please send me through WhatsApp.